I'll get started. I know almost everybody's back, but I know we have a lot of material to cover this afternoon. So we're kind of going to switch gears out of subpart A, kind of more general, affecting everybody type regulation to some more very specific for different business sectors. So first thing we're going to start off with is subpart J. This is specific to refineries. So I mean, if you are a chemical manufacturer, you do not, this rule doesn't apply to you. As we talked again earlier this morning, it was published, it's an older rule. It was published back in 1978, and it's been amended numerous times. So I mean, there have been changes to the rule as the knowledge base has grown. Most notably, it was changed on September 12, 2012. Basically, that's the date that JA got published, and it basically put in the caveat that you can just follow JA instead of J. So that was nice of them to let you out of that box. Because otherwise, you could have people that would have to comply with both J and JA. So they said, if you were complying with JA, you no longer have to comply with J. So it let you out of that trap. The interesting thing about NSPS-J, because we're so used to now talking about JA and where flares is an actual affected facility, back when it was J, it wasn't. The flare was not specifically called out as an affected facility. It was under the category of fuel gas combustion device. So I mean, they kind of regulated it just like you would regulate a boiler or a heater. So I mean, it's going to operate very different than a boiler or a heater, but they decided to lump it all in there. And for J, you also got to just think about that, this is an NSPS, so again, it was focused around sulfur dioxide emissions. So I mean, it's not concerned about how combustion efficiency or anything like that. It's about reducing sulfur getting to your flare. And then it came with the so it was considered a fuel gas combustion device, and then it didn't define what the flare is. So I mean, it's like, okay, is the flare just the stack? Is it the header? Is it the knockout drum? Is it the water seal? There was no definition that said, okay, these are all the bits and pieces that we call a flare, and so if you modify any of those things, you now have a modified flare that's subject. So there was a lot of ambiguity with this rule, and so a lot of facilities said, oh, no, we never modified our flare. We changed part of our header, but that's not the flare. So we didn't actually change anything. We didn't modify our flare, so they didn't take on J applicability. So, when we get back to that modification, you get back to that whole increases any air pollutant. I mean, that's pretty standard across, the NSPS definition of a modification. And so you're looking at, okay, if you increased the size of your flare tip, so you can now physically get more material out of your flare tip, then of course that's pretty much a clear, you've increased the potential to emit pollutants. So that was kind of the one. So people were like, okay, if I made some other minor modification, did that really increase or change how much emissions were coming out of the flare? And everybody tried to argue that no, they did not. I was looking on the ADI, which we'll talk about a little bit later. There actually was an ADI request that was made for NSPS-J, and they was talking about, we added some connections to the header, and this ADI came out in 2008, and it actually, the EPA said, yes, you adding connections to the flare modified your flare. So I mean, it was kind of getting right into that time frame when NSPS-JA was going to come out, so it was, they were starting to think of that concept of the flare is more than just a flare stack, and if you make a change to what's going to your flare, now you're triggering that modification. So again, they had like all NSPS had a operational limit because, again, you're not installing a SEMS on the outlet of your flare. We all know that's rather difficult. It came with a requirement to limit the amount of sulfur in the fuel gas going to the flare. So that's how you would do the monitoring. It contained that same exemption for process upset gas, which can be an important exemption for flares. So, when you have these limited use flares, this one can become, very key to meeting those regulations. And it gave you that same, which we'll see again in NSPS-JA, this relief valve leakage and emergency malfunctions are exempt from the limit. So there came with a couple of different monitoring requirements, pretty much as it was modeled after other combustion devices. They had the option for post-combustion monitoring, but of course we know that that is not possible unless you have maybe an enclosed flare that had a high enough stack, you'd be able to have ports on it. But otherwise you're looking for that the H2S monitoring. And again, geared after that, it could be a boiler or a furnace. It also put in, you can monitor that sulfur concentration on a common fuel gas mix drum, thinking that that's the only gas that's going to the flare. But of course, a flare doesn't only get its fuel from the fuel gas mix drum. So I mean that monitoring wasn't widely applicable to the flares. The instrument span number we see again in NSPS-JA, the 300 ppm. But again, it was only H2S monitoring. There was none of this new business that we'll talk about later today with the total reduced sulfurs and all that, the root cause analysis thresholds. There was none of those things. It did come with some of these caveats for inherently low sulfur gases. Gave you some alternatives where you don't have to do the monitoring. But even with these type of exemptions in it, there was still just an incredible volume of amps that were requested for NSPS-JA to get other types of fuel gas streams out of the monitoring. And just so through that modification and how did you modify your flare, and everybody saying, well, no, this isn't, I didn't trigger an SPSJ. Well, that was where, I guess the EPA showed some frustration in that they felt that more flares should have triggered J. They were surprised that people weren't saying that they had J flares. So you had a lot of people, or a lot of refineries that through the global consent decrees, they accepted J applicability for their flares through the consent decree. So I mean, that was where they kind of came in and said, no, you guys really need to take J applicability for your flares. Well, that was quick. So we didn't spend a lot of time on it because we think that almost everybody has moved beyond J to JA. We do still find some J flares out there, but it's somewhat of a dying breed. And but yeah, any questions on that? I know we only have a few refiners in the room, so all right. Let's see. But yeah, I told you that the afternoon would go a lot quicker than the morning.
Yeah, the team chided me a little bit over lunch for sucking up too much time on the simplest of all subparts days.
Now that's not true. we said we had a lot of fun hearing all the good feedback, so that's what that's why we weren't giving Troy the old, cut it off. This is going to be another kind of more specific rule. So again, we're not going to spend a lot of time on it, but it kind of sets the stage in that through the rules in Texas and specifically the HRVOC rules, this really created the drive for some of the monitoring instrumentation to be designed, built for flares, and troubleshooting for flares. Without this rule, there wouldn't have been so many more robust solutions for flow monitoring, composition monitoring. Every time a new technology is going to get put out there, there's going to be a time when we're using this as a new way. What are the issues? And so the HRVOC rules really provided that place for all that ingenuity. Just a little overview. The HRVOC area in the Houston, Galveston, Brazoria County, it's a non-attainment area for ozone. So there's a lot of focus on how to get into attainment with ozone. I mean, you got two choices. It's controlling NOx or controlling VOCs. So you can see that they're really, you need to, what can you control? And so they found that the highly reactive VOCs were really some of the things that were driving non-attainment. So there was a lot of focus put on it. Here you can see some data that's kind of just showing the concentrations over time, and see that yes, there's been huge gains in the quality of air. Yeah. So one of the things that kind of brought this focus onto flares came out of a TCEQ air quality study back in 2000. There was an event, and I don't think we even know which facility this was. Maybe I don't know.
No, they wouldn't. I know for a fact they wouldn't fly through the plume.
Yes.
I don't know what's in the plume.
Oh, okay.
They wouldn't fly through it.
Yeah. But so we have a facility that's having an upset, and so we got definitely some flaring going on, and so you have we've been told that there's multiple flares in this picture. You can't see them all that well. There's one here, the really tall guy. You can see it ends about there. That's the smoking one. Then you have another flare that's here. You see a nice flame on top of it. So that one looks pretty good. And then we were told that over here, there's another smaller flame or flare, but the one thing you don't see on that is a flame. So the thought is that they're having this event, and they're going to have these emissions that are coming out into the atmosphere. Where are the VOCs coming from? And most people, when you think about a flare, you go out into the public and ask, which one of these flares do you think is causing the problems? Everybody's going to point to this nice one that's smoking, and everybody's going to say that's the offending flare. But actually, it's more likely this little guy over here that's got no combustion going on. So they took the data from this event, and then they wanted to use the models to try to reconcile the event with the models to say, okay, are our models accurately representing what's going on? And the thing is that they couldn't get the models to match. It just wasn't working out. And they found out that they would have to reduce the combustion efficiency of the flares down from 98% down to 90% efficient in order to get the model to match the emissions. So this really started to say that these flares could be a significant contributor to air quality, and that's kind of you got to think this is back in 2000. So I mean, this is definitely spurring those thoughts of why do we need to focus on the flares, because it could be impacting air quality. So based on those studies, Then it came about the HRVOC regulations, just basically targeting, you know, the Houston, Galveston area. You know, it's a you know, relatively highly industrialized area. There's lots of petrochemicals going on there, lots of refining. So a lot of sources of HRVOCs. So these were seen as the compounds that they wanted to, you know, go after to try to reduce the ground level ozone. So I mean, the HRVOC rules were, you know, part of the SIP, and so they had various different places that they wanted to reduce the HRVs, mainly flares, process vents, cooling towers, and fugitive emissions. And again, the whole concept of we have a rule, we can make changes to it. This is a thing that you need to do.
We spent $40 to $60 million in 2000, 2006 studying air quality in Houston and East Texas. And one of the main findings from that spending $40 to $60 million is we got a lot of unknown hydrocarbons in the air. Which is a joke, right? Because you can smell it down there. Maybe everybody had been down to Houston. So out of that 2000 inventory, out of that 2000 study, 2006 was a follow-up. The 2000 study estimates were the emission inventory, that's where I work, were off between 6 and 100 times compared to what they're finding in the atmosphere. Basically, they're rationing it to NOx plumes. So we got a good number, we got a good grip on the NOx, right? But we don't have a good grip on the VOC. So out of that, we learned a lot, and that's where the HRVOC rules come in. And since then, I've been on a personal mission myself to improve the inventory as much as I can. We do research on this. We find, every time we do a project, we find all kinds of unknown hydrocarbons going into the atmosphere. So it's interesting to see that. For example, in 2006, we saw the tanks that were landed, the gasoline tanks that were landed, and the plumes would go up into the atmosphere. There was a 50% increase of hydrocarbon, a 50% increase of VOC in the ship channel area because of these tanks, that one tank in one condition. It went 50% increase of VOC in the ship channel.
One thing.
No, from one.
Oh, from one operation.
One condition, from tanks in that one condition, from one source in one condition. So there's lots of hydrocarbons out there that we got to get a control on even now. I mean, you see the charts going down, and I'm very pleased to see that. But there's other things out there, and the flares, in my opinion, are the most important one because, I mean, what we're seeing, things are completely unlit historically, but they're getting better. So we learned a lot from, we spent that money and we learned a lot from it. Mm-hmm. and learning, still people using that data to do analysis. So it was money well spent. And that rolled into the HRVOC rules. And I think in my observation, the HRVOC rules on the flares didn't really decrease HRVOC in the atmosphere, okay? But what it did decrease was HRVOC going to the flare header because once the flow meters were put on, everybody realized that there's a lot more hydrocarbon going in their header than they realized. So just the very fact of stopping that, going to the flare, made the emissions go down. Now the cooling towers, that was very effective in my opinion because historically it's cheaper to let it leak than fix it. So that has, I think, been a big deal in lowering our ethylene and propylene.
Mm-hmm. Yeah, we see that aha moment happen at a lot of facilities when they put their flow meters on their flare headers, because everybody, you go and talk to them, and their first thing is, oh, we don't flare, and all of a sudden they've installed the flow meter, and they're like, wow, we need to get some projects in place to reduce this flaring, because suddenly there's an actual number, and somebody can always put a dollar value associated with that number, and suddenly this is an important issue. So I mean, it's kind of one of those things with the flare, and especially if you don't have a nice big ball of flame up there, you don't have that thing reinforcing in people's minds that, yes, there is a significant amount of material going up, and it needs to be handled. So yeah, so the VOCs were regulated. It was 3 counties, the main ozone non-attainment area. We already talked about that. There's one of the things that's interesting about the rule is depending on which county you're in, there's a different list of components that you're looking at. So I mean, in Harris County, you have you know, the largest list, and then once you get farther and farther away from the Houston area, that's when it drops down, and you're primarily concerned about the ethylenes and propylenes. So I mean, one thing that really what this rule did was added the requirement for monitoring. There was the installation of the flow meter, and there was installation of a compositional analyzer. So I mean, those were the two biggest things that people had to do. So I mean, there's some reporting that has to be done, and there are exemptions. You know, we'll talk about various ones, but you know, if you have a low enough threshold of HRVOCs in the gases that go into the atmosphere, then you can, of course, get out. So the continuous, the data, you know, it's used for hourly emissions. They have to calculate the minimum heating value and the exit velocity, you know, all the time. So I mean, it really changed from the, oh, sorry. You know, so you're having to, instead of doing that one-time performance test for 60.18, now you're needing to show compliance with this on an ongoing basis. So that was something that was new for people. So I mean, it was the start of the process. You're going to have, again, but of course all flares aren't created equal. So you're going to have, you know, loading, unloading flares, emergency flares, temporary flares. I mean, these all have various exemptions. So they don't have to do the full-blown monitoring in all cases.
And continuous is defined as, what, once every 15 minutes, or what, continuous monitoring data must be used to show compliance?
Yes, it's every 15 minutes.
I think 1 hour block averages.
So really?
It usually gets calculated into 1 hour block averages for the compliance.
Yeah, it's usually, yeah, I think from like the composition data is every 15 minutes and then 1 hour average. Flow monitoring. So, you know, so they're having to meet the BTU requirements for 60.18. So this has caused a lot of facilities to have supplemental gas. You know, we find a lot of times when we go to places, the concept of supplemental gas, it's just not there. So I mean, people don't feel that they've had to have added gas, but in this area, because they had a compliance point and they were monitoring for it, suddenly people said, well, we have to have a way to control for that. One of the little nuances is this where that supplemental gas gets put in and how you monitor for it. They kind of specified some things that aren't specified in other rules. With the supplemental gas flow, your flow meter doesn't have to be in a spot that measures everything. You can have one flow meter for the vent gas and another flow meter on the supplemental fuel. You can use just a velocity monitor. It has, you can see here the calibration requirements, a little more robust than other places. But it has our temperature and pressure monitors to correct everything back to standard conditions, which pretty much everybody's comfortable with. Here's the every 15 minutes. You're going to have that composition monitoring. But then one thing that they changed here was that for the composition monitoring, now you have to have your monitor downstream of the supplemental gas addition. So I mean, this, you know, so then you're great. You say, great, I can have that 1 meter measuring for 300 BTU per scuff, and as long as that reads 300 BTU per scuff, then I'm in compliance. But then it's through doing all these different, you know, control projects on flares, and people are adding it in, the math gets a little more complicated when you're trying to control your system, because now you can say, okay, I'm over 300, Well, how much of that is supplemental fuel versus what was in my vent gas? So now you have to be, if you want, because the big driver is, I want to always be minimizing the amount of supplemental fuel I'm adding. So you always want to be able to back that amount of gas out to say, wait, I only need, 100 scuff per minute of natural gas right now, not 50. So I mean,
the rules don't allow you to measure vent gas and the supplemental gas flow and then calculate?
That's what you would have to do. But the composition analysis must be when they're together.
Okay, so you have to measure it.
Yeah, so that's where that flow meter on the supplemental fuel line becomes critical. Otherwise, you could just be pumping a bunch of fuel in there and saying, well, look, my number's great, but you're wasting a lot of extra gas. So it's just from a minimization standpoint that you're going to want a little more robust monitoring on this system. Some of the other ones that pretty much have followed suit with a lot of other things, the calibration, you're following the PS9. A little bit, so they had some other minor differences just on the multi-point calibration, and the mid-level is the once per week rather than the daily. If you're and this is for the high HRVOC constituent. So I mean, they even specified it that much more, so that you have to do, so you have some extra steps for the HRVOCs, but then non-HRVOCs, you're following the manufacturer's specifications. This is a nice one. It says that the range, how you're spanning these analyzers is for the typical case, not for your maximum cases. So I mean, that can really help you out with your calibration gases and some of the concepts that we're going to talk a lot about tomorrow. There's going to be a lot of discussion because the refiners are having a lot of problems with your high concentration H2S cylinders that are now required under NSPS JA.
By the way, this thing has been progressing. JA was 3 years in the making, implementation-wise. So a lot of the Houston area folks felt, hey, I got this under control. I don't need to worry about this. I got my flow meters, I got my analyzers, life is good. Y'all go focus on other refinery flares someplace else. Now that we're down to the last couple months here before JA kicks in, we're taking a look at these flare systems that are under HRVOC, and there are these little nuances that are kind of tricky. Even the once per quarter, 3-point, multi-point calibration once per quarter, not once a month. That has to be done in triplicate. The really interesting one is that mid-level calibration, once per week. That's a triplicate run, 1 time a week. So if you're ordering an analyzer from somebody, the guys at Yokogawa or Siemens or somebody who's doing the GC work for you, their data management system, their DOS, is probably designed for a daily cal, not one in triplicate in the middle of the week, right? So all these little data capture things we just got to be aware of, and you got to do both.
Yeah, anytime you're going to have that multiple rules over a single system, you're going to have to comply with all of them, not just whichever's most convenient. The instruments, they have a 95% on-stream time required. If you're down for greater than 8 hours, then you're going to have to grab a sample. So there's a big push to keep your instruments up. Here's our little joke. We put this picture in, and then we noticed the beard. And I was just like, that guy's not in a refinery.
That's the young guy down in the shop, right?
Yes. I don't think he got let through the gate, so it's.
We only make fun of this because Derek, our good friend here, green shirt, Derek took a bullet for the team here. His very first site visit 2 years ago. When was it? Yeah, he came to work for Sage with a beard, and he shaved it off to go enter his very first refinery 2 years ago.
Yeah, in the bathroom in a truck stop on the way to the site.
I just changed it off the parking lot one time.
Yeah, it was, I love that. He's like, yeah, Troy said, we're getting off the plane, and Troy looks at me and goes, huh, yeah. So yeah, everybody's got to shave.
So a lot of sites, by the way, skip this 8-hour downtime. In the HRVOs, we're finally having a chance, they're inviting us, and we're finally starting to look at what they have, because they felt very comfortable that what they had was great. It may be great for JA, but now we're seeing some little interesting HRVO2 things that maybe they need to tighten up. One of them being the ability to grab a downtime sample if you're out for more than 8 hours. Some people do not have that automatic ability built in. And they may have missed some of their 8-hour obligations.
And just having a sample point can be a challenge, because I mean, you know, we go to some facilities, you know, do you have a closed loop sampler? I mean, or you just, some places say, like, you know, we have a ladder or a platform that we can get up there and attach a sample bomb or a syringe and pull a sample. You know, other guys will say, we'll go out and say, oh, well, we have this tubing run down the grade, and then we're like, well, how do you handle the purge? Because I mean, otherwise you have this tube that's going to be half or all full of oxygen, and you're going to take your sample, and suddenly that whole tube volume is now in your sample bomb. So it's like, you know, it's going to be diluting the BTU content that you so greatly want. You could be diluting unnecessarily with not having the correct samplers. So there's a lot of, but there are, you know, we have seen some places where they do have, you know, systems set up that will automatically trigger to get to grab a sample, and we'll have multiple, you know, canisters lined up so they can get that sample grabbed automatically over a number of hours. So then there's, of course, the exceptions. So I mean, if it's like, if you're not getting your HRVOCs to your flares for, you have to give you 336 hours, then you're only in temporary service. So then you don't have to put on the flow meter. You can just use process knowledge. I guess the flow, if you also have a flare that, you know, a main flare and then a secondary flare, then if that secondary flare only operates a few hours a year, then you can also use kind of the flow estimation off the primary flare for your secondary flare. The composition, you get down to, again, a daily sample. You don't have to have that online analyzer. So similar type exemptions for loading flares. I mean, it's one of these things, we've seen this even for, you know, we'll talk about amps later, but, you know, it's like if you have a flare in a dedicated service, and if it's a loading service, I mean, we have nice programs that will calculate your emissions from loading. I mean, you know what that flow is. I mean, you've got displacement volumes. I mean, it's not like there's a lot of other flows in there. So, I mean, why would you need a flow meter to give you those numbers? So those ones are taken out from the rule. One thing this one does is, instead of speciating, you're given the option of a calorimeter. So it's just making sure you have that high BTU. And then, yeah, because then you can also use calculations if you're always in the same service and you know what that composition is going to be. There's no point in installing a analyzer. Okay, MSS exemptions. So again, it's you got the hour limitation, again only for maintenance, startup, and shutdown. So very specific use flares. Again, for flow monitoring, you can use the calculations. Don't have to have the monitoring. You can use the calorimeter instead of the composition analysis. And again, if it's in the same type of service where you're going to know what that composition is, you don't need to put in the analyzer. Emergency flares. Very much similar. Again, you have the exceptions for flow monitoring, but it's a process knowledge if you have that seal system. So you know that gases cannot get to that flare on a routine basis. You have that physical barrier to the gases. If you don't have that seal system, then you do need the flow monitor, but you don't have to have it on the supplemental gas flow. And again, if this is only going to be happening for emergency type situations, you don't have to have the composition monitoring. One of the things that they had to do, which kind of kept with the everything after this, is kind of kept the same theme, is let's have a rule, let's have a plan that we can have to create to document what we're doing. We're going to see this over and over again, where the governing body wants to know, how are you complying with these rules? I think, it's, at least from my point of view, I kind of think of it as like, yes, you want to know and have a nice documented place of how am I coming into compliance with this. So, if somebody, when the inspector shows up and they ask you, how are you complying with this? Well, you pull the binder off the shelf and you say, this is exactly how I'm doing it. So, I mean, it's definitely something that's good to have, and it puts everybody on the same page. So when somebody says, why do we have this analyzer here, and why are we looking for these specific constituents, you now have something that will make it nice and easy to explain to people. Similarly, if you have an emergency flare, you're going to have a different plan for that. And then you can see here just some of the different data retention periods. So, I mean, pretty typical for people, similar to like the Title V 5-year retention times. So another thing that they added was a very nice thing, is that they gave you compound-specific DREs. So not, it's instead of using the typical 98% destruction efficiency, now depending on what those constituents are, you have, 99% for your ethylenes and propylenes, 98% for your other compounds, and then they give you a number that to use when you're not meeting these criteria. That's some of the things that people say, like, okay, well, if I'm not meeting everything, well, how much am I emitting? And a lot of people don't, I don't know what, without having a PFTIR out there looking at my plume, I don't know what's actually coming out of my flare. So, I mean, it gave you a number, though, to use. You see that in a few of the consent decrees where they were given, a table that showed, if you're meeting this, not this, you can claim this much destruction.
You know what? Go ahead. So they're required to set their permit limits based on that?
Yeah, I think when if you're doing doing your permitting, you're going to use the
higher percent. Yeah, we're allowed to use the 99, 98 for the permitting. 93, we sure as heck don't, because that's
yeah, you don't permit for not being in compliance.
Right.
What's the rationale for the higher DRE for ethylene propylene? Do you know?
It burns really
Yeah, I think it's expected to burn very well.
So it's kind of like what the opposite of EPA thinks. The new rule says it burns worse. The refinery rule. Yeah, that's interesting.
Yeah.
I don't know, man.
Yeah. No. In Max CC, yeah.
Just wanted to bring that point out. I was curious so they actually. Okay, so they think that's the normal state of affairs.
Yeah. It's one of those things. It says, especially with the smaller, lower C.
DCQ's got a guidance document that has a subset of chemicals that are really good combustion, and they allow you to permit at a high combustion percentage on those, and it includes those too.
That 99 for ethylene propylene has been around for quite some time, probably before I got there. So I don't know what the justification is, but I know it's been around.
Okay. I was just curious.
It just goes back to that CMA document, 1983 or whatever.
Yeah, and we'll talk later about the other thing, the Max CC hydrogen olefin interaction that Max CC has brought up. And then also for the HRVOC cap rules, you have the cap and trade program. If you have the PTE of more than 10 tons of HRVOCs in a year, then you get to be in the program. So again, it's like similar to many cap and trade programs where it's just you get certain many allowances for your emissions, and then capped in order to meet the NAAQS. All right. Back to the paging Dr. Bowley. Yeah. Yes.
I always say that, it never ends up.
Yeah, on this one we
It's
will.
almost as easy as the 4A.
The next three should go fast.
Don't build up our hopes.
We already asked the question, right? Does anybody have a California flare? And nobody in the room had one, right? So we're done. Ah, that's right. Yeah, that's right. Phillips has one in Rodeo. Oh, yeah? You don't have one in San Joaquin Valley, though. And that's the problem. Well, that's good for you. All right, really fast. 35 air districts in California, for those of you who are playing Trivial Pursuit tonight somewhere. Each one acts as its own little individual state, right? There's a SIP, kind of a SIP plan for each zone. So each air quality district kind of operates on its own. The Bay Area, South Coast, and San Joaquin have flare rules. Each of them are kind of uniquely developed. They look very similar, but there's a few little nuances. That's all I wanted to point out, is just to make you aware of what the nuances are. So Bay Area, of course, is San Francisco. 5 refineries in the San Francisco area. Those 5 refineries are the only ones subject to the rule. South Coast has a little bit larger zone of refining, hydrogen, and a sulfur unit. That's covered by the rule. And the one that's unique is San Joaquin. San Joaquin actually applies to all flares. So it doesn't matter if you're in the chemical sector, the refining sector, or anything. So it's a little bit broader in its applicability. For the Bay Area, the rules go back a little over 10 years. First one is for monitoring, and the second one was for minimization. So the monitoring one basically is for the sulfur, and we have a little list here of H2S. So that's why a lot of people say, I need to measure the sulfur. I'm going to do what the guys in California did. They use a SOLA 2 just for a low span H2S. All of this was low span only. Nothing in California requires that high span H2S or high span total sulfur that we're using for JA, right? We're going to start seeing some overlap here. What's interesting, though, that a lot of people like to go online and read are these flare minimization plans. Every year they have to write a flare minimization plan and update it. So that's really cool. It's an awesome source of information to go back in time and start collecting as many of these old ones as you can. You can actually see how each individual site changed its flare minimization tactic year over year over year. It's kind of fun to see how they did that and what they included, or what was not included, what they considered confidential business information, what they considered publicly digestible. So there's a lot of information out there. It's kind of fun to go back and look at all of these. What's really interesting too is that they're posted on the internet by the agency. So they usually keep last year's and this year's up there. They start falling off after a couple years. Let's see. Here's one of the interesting things, a flow verification report every 6 months on their panometric flow meters. Almost all of the sites in Bay Area have panometrics. Every 6 months, everyone's still scratching their head, even after all these years, over a decade, trying to figure out, what am I verifying? It's an ultrasonic. Those of you who have played with these, you know, you pull out the transducers and go, yep, they're still there, put them back in. There's nothing to calibrate. There's nothing to adjust. There's no gain knob anywhere that requires you to tinker with it. So it is or it isn't. So people still do these every 6 months. Nice little side job if you want to retire and play with flow meters, I guess. There's a whole bunch of them out there to do.
Do they require any flow on the, I assume some of these are assisted flares, right?
Right, so it's only flow on the vent gas.
No steam flow requirements?
No, or supplemental. And the vent gas composition is choice. So every option under the sun was written into the rule. There are people who do daily grabs. There are people who do integrated. There are people who have continuous monitoring in place. It's just all over the map. So when JA came out, it forced everybody to a continuous H2S. And so that's why some refineries in California were perfectly fine. Others were not. Some of you may remember in JA, when we get to that, I know we're bouncing around a bit, but JA has a cool little statement that says, hey, if you're subject to the rule, but you're in the Bay Area or LA, South Coast, hey, you're exempt. No, 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 no. You're not exempt from JA. You're just exempt from the what? What part of JA? The flare management plan. You still got to have the monitoring and everything else that JA requires. You're only exempt from doing the monitoring plan. And a lot of the refineries at the beginning of this thought that they had a pass. And then when they got caught with a rapid request for capital dollars to put in some instrumentation. What also is interesting is they do have a total hydrocarbon analyzer, a methane, and H2S, or the total reduced sulfur. Or TRS is the allowance for the SOLA 2 by Thermo Scientific. Of course, methane, these are greenhouse gases, so we're in California, so they count all those molecules. They do have a requirement for pilot monitoring and flow gas flow monitoring. Presence or absence of, not quantified. Presence or absence of. So most people have a RO or some restriction orifice, for the purge. And the other thing too is video monitoring wasn't required at all times. It was based on if flow were occurring. So many of these sites in the San Francisco area have mandatory flare gas recovery. There's a water seal. 99% of the time there's no flow, so there's no requirement to be monitoring all these things in those periods. That goes back to the 60.18 requirement, right? Must be meeting all these requirements when flow is directed to the device. For the minimization plan, these are really kind of fun to read. I don't know what I'm a weird guy. Yes, thank you. We've gone back a couple years ago and printed off all of these and compared them. We did a compare and contrast. We did a review of what were the minimization techniques that these sites identified. Because we thought, hey, if they spent a decade writing all these techniques down, maybe some of them could be transferable to your site. So what were some of these internal things that they did? It's kind of an interesting study. We don't have all those results here. We gave a presentation at AFPM on that I can probably try to dig up somewhere. It wasn't as enlightening as you could imagine, because at the end of the day, guess what every plant did? Made Roger back here at John Zink a very happy man. They all went with flare gas recovery. Yeah, so instead of minimizing inside the plant and at source reduction techniques, it just got so convoluted and complicated, it's just a whole lot easier to spend the dollars to do the flare gas recovery. But they're fun to read, I think. South Coast, now we're around LA, 7 different refineries, 3 hydrogen plants, all of them under this jurisdiction. There's only that one SRU. Sulfur recovery plant. In total, between those 7 refineries, there's 30 flares covered by the rule. Same thing. You can go online and take a look at their flare plans and everything else. Their words are a little bit different. They actually came up with a ton SO2 per barrel emission limitation. So this is something that JA did not do, and the federal rules do not have. This is only in South Coast, where they came up with, over time, a decreasing number down to half a ton of SO2 per million barrels in the refinery. That's the noon limit. And as far as I know, everybody's meeting that except for one site recently, which I'll touch on here in a second. They, I'm trying to remember what I wanted to, I didn't want to go through all of this in detail. I just wanted to point out something important, and now I can't remember what it was. Oh, the calc. So clean service, they don't have a definition for inherently low sulfur, but that's what the clean service means. If it's low H2S, clean service, they don't have to do all of the monitoring, they can do calculations. The difference is for most general flares, you're doing the flow, the higher heating value, BTU count, and the total sulfur, all three of those, all of those on continuous. Total sulfur is supposed to be your choice of either that grab, integrated, or the daily. I mean, or the continuous, right? What has to go into the plan? What goes into the plan is very similar to what's in the flare management plan for JA, very similar to what's in for Bay Area, so nothing too unusual. People got really wigged out over this part, the technical data, the process flow diagrams, and the drawings, and the technical specifications of their equipment. Every single one of these refineries has put all of that into CBI. It's all confidential business. It's stripped out of the public report. San Joaquin, this is the one that's a little different because it involves all flares, any flare inside the jurisdiction. So it includes a lot of interesting stuff, including wastewater, triple W sites, those are municipal solid waste landfills. Any source where there's 10 tons of VOC, 10 tons of NOx can be exempted out of it. So there's a few things drop out, but most every other flare in the county is under the rule. It has some really interesting things. Probably the most amazing is this Coanda effect. It's the only rule in the country that uses the pressure-assisted Coanda effect as an exemption. So in the rule, which is a SIP-approved rule, right? So it's an Air Quality Management District. This is EPA SIP-approved. If there is a Coanda effect, a pressure-assisted flare, you're exempt from 60.18 tip velocity. We have used this argumentation with many other states, North Dakota, Wyoming, South Dakota, Colorado, people who put in pressure-assisted flares in the oil and gas industry for Quad O or for other places. We try to say, hey, we're not building anything new or unique. The Coanda tip goes way back in time. Back in the 80s, they were tested. San Joaquin understands their effect. The gas comes around the top, and because of the velocity of the gas moving faster around that tulip bowl, it induces more air automagically into if you're following up on the Bernoulli equations for your aeronautics, for those of you who took aeronautical engineering, pretty cool effect. And it works. It's brilliant. It's a great idea. So we do use that discussion point quite a bit when we're trying to get a pressure tip velocity allowance.
The typical pressure-assisted flare tip doesn't have that design, does it?
Some do, some don't. So there's a couple of companies that make this design. I think Zinc actually has one in this design that they sell and market. But nowadays, the more common pressure-assisted is the star, right? I forget what they call that. The star pattern with the little arm branches and the drilled holes or the slots that allows air to come up from the bottom underneath. It just sucks it in.
And that's a much higher velocity than this?
Oh no, these go sonic as well. Can you hit Mach 1, Mach 1.2? Yeah, they're pretty fast. They definitely sound like a jet engine. These have a little bit louder ambient noise level.
They're elevated.
Well, the ones up in North Dakota stand about shoulder height, so some of them are pretty short. Same thing with the flare minimization plan. But what's interesting, for some reason, and we've never gotten a clear explanation from EPA, maybe some other people in the room have heard, why was San Joaquin Valley not allowed to exempt themselves from the flare management plan in JA? They have to do an FMP under JA. Even though they have all these flare rules, their county has to still do it. I don't know why. I don't know. It's almost like they didn't know they had a set of flare rules and somehow it got missed. And it's not that many plants, but still, if I were the refinery in San Joaquin, I'd be upset. So there's, you can elect to do the applicable state instead of JA. They're supposed to be equivalent, but only for the flare management plan, not necessarily for the high span and flow monitoring. Pieces may be slightly different. You're not given that exemption for San Joaquin, sorry. And this is what EPA said, minor differences in terminology. Well, what does that mean? I don't know what that means. Somebody who had a bad day, I guess. One thing that's interesting about California that we didn't get in the refinery sector for JA is the requirement for flow limitations, the actual volume of material you can send to your flare. So in California, they've set these volume limitations, and they're kind of all over the place. But remember when JA was first being proposed, people were quite nervous over the 250,000 scuff per day, right? That's not a whole lot of volume. And that came out of the federal rule. That number shows up in quite a few of the California rules. And obviously in many, if not most, all of the consent decrees. There's a volume limitation as well as a BTU limitation. Operational limits, typical reporting. You can't do anything without telling everybody about it. They do have a startup shutdown and malfunction, and they use this cool little word, other essential operational necessities. So that means basically by petition, you can say, hey, I had a unique circumstance, as I understand it. They do require this is something that nobody else has, only in California, the pressure relief device survey. So South Coast, those 7 refineries have this annual acoustic or temperature leak check on every relief device into the flare header. So not everybody does that. It's a good management practice that a lot of people seek to do using the VPAC2 or some other acoustic device, walk around, survey the plant. We've done quite a few of those as well. It's voluntary. There's nothing in JA that demands it. It's only required, we think, at South Coast. But there's some interesting stories we can tell about those acoustical surveys if you're interested. And the temperature leak survey is basically using your FLIR camera. Most of you own a FLIR camera. Using a FLIR camera upstream and downstream of the relief device, just looking for that temperature difference as an indication of a potential leak by. I'm going to skip that because it looks pretty straightforward. This is what I wanted to show you. We used to have license plates. I used to live in Texas, and it used to be don't mess with Texas. Well, as of last year, there's a new phrase in the flare world, don't mess with California. There's a little story behind this, and it's all public, so I don't mind telling the story. And there's nobody in the room from Exxon, right? So we get to throw them under the bus a little bit here. Last year, April, this was really quiet. Many of you may not even know this happened. There was an assigned agreement with South Coast. They had 3 flare lines going to 2 different flares. So they had multiple connections to 2 flares. They operated kind of as a cascaded system. So routinely, the system has a flare gas recovery, sucking lots of material back in for reuse. They have a low flow enclosed combustor that's not a flare. It's an enclosed combustor for the low flow case. And then during the oh my God moments, the big flares go off. During a turnaround, sometime in the past, in a galaxy far, far away, they took and opened certain valves and allowed flow to be diverted through this giant network. And when they went back into service, I don't think they quite realized it, that the flow was only going through part of one of the flow meters. Half of the flow was being routed back through these giant, massive valves, and somebody forgot to close the valves. So they had flow through to their big, tall flares, even though they thought they had no flow. So they estimated that whatever number they reported, they probably flared more than double than what they thought they did.
But at least they were lit. Were they?
Well, it's kind of hard to say because in their world, in a cascaded flare system, you have monitoring on which set. Right? So the first flare gets the flow, and the first flare gets the analytical. Right? And that's my primary flare. That's what I'm going to monitor. If I'm letting something go around it to a secondary flare, you may not have all the instrumentation, and I only have to monitor it when it's in service. And for the last 5 years, they thought it was out of service. Oops. So the thing that really caught my attention, aside from the whole drama of the whole story, is the numbers. $8.1 million for bypassing a flow meter. Pretty remarkable. In fact, it's outrageously remarkable. But that's not the end of the story. There's mitigation fees and back calculation fees. So there's an additional 14.5 for these mitigation fees, of which they paid 50/50. And then, of course, the emission fees that they paid to the county for what you actually emitted was an additional $300,000. So in the end, I don't know what that worked out to be, $22.6 million. That's a pretty expensive flow meter. That's a pretty expensive valve that we forgot to close. So it's been kind of on the quiet hush-hush, and I'm sure Exxon understand. You can all appreciate why Exxon is not too proud of this moment in their history. But it just goes to show that little itty-bitty tiny things, like a bypass around a flow meter or something like that, when it comes to the world of flares, flares have a crazy high sensitivity right now. People are really zoned in on this. And something as simple as a flow meter bypass, which maybe wasn't so simple. Granted, I don't know what the actual emissions implication was, if any. But I just use this as a little reinforcement to us that little things are important. So let's pay attention to the details. Landfills. I think I have landfill. Now, we already determined that nobody in here has a landfill flare, right? So this is a fly moment. All right. Why is that not working? I can't see. I know I want one of those. Somebody with better eyes. Go. All right, 13 slides. This is going to go fast. 13 slides. Landfills are cool places. I'm not sure how many times you get to go dumpster diving and go checking out landfills, but if you haven't done it in a while as an environmental professional, you ought to go do it. It's kind of a fun place to go on a weekend vacation.
You're right, it is.
Yeah, landfills are not exactly the highlight of anybody's weekend, I'm sure. They do have some interesting gas combinations. What's really cool is the concentration of CO2 can be really, really high. The methane numbers obviously are high. What they do is they put these blowers, and they actually, blowers or vacuums they basically suck the air out of the landfill and send it to a combustion device. Naturally, you have to supplement it because sometimes it's not combustible on its own. There are some fun, interesting problems with landfill gases, including the odors, not just odors, but the H2S odors. And it's not exactly, they don't use chemical plant refinery type operators at landfills, so they're kind of prone to this problem of blowing up their flares. Blowing up their blowers. They're not as attentive to combustible mixtures as you are at your plant. Let's just put it that way. So naturally, there's rules that actually require proper management of the landfill gas. There's a whole bunch, nearly 2,000 active landfills in the U.S. A whole bunch of them, 700 or so, are affected by the current New Source Performance Standard. Just if you wanted to see where they are, they're everywhere. They're around every corner. There's a bunch of them. If one of the things that the new landfill rule requires is every 100 feet or so, 30 meters, a method 21. You actually get to take 10 centimeters off the surface of the ground cover with your little TVA, take a reading, and then you walk another 100 feet, take another reading. They're doing method 21 on their landfill covers, which just blows your mind. Those of us in the instrumentation world just shudder at the thought of reverting back to an old-fashioned method 21 manually intensive process when there's so many cool optical techniques out there that could be doing this for them. The regulatory applicability goes back to 1996. People have been doing this for a long, long time. Subpart WWW is already out there. Basically, it's based on the size of the landfill, the number of emissions estimated per year. Obviously, the age of the landfill affects the emissions estimate, right? So older landfills tend to have higher methane emissions. And whether or not a control is required usually is for the larger landfills and the larger emitters. Let's see if I can fly through some of this stuff. Most people want to collect that natural gas and burn it in an engine, right? Collect some heat value out of it and make some electricity. Massive problems in doing that. Whoever has played with biogas-fired combustion engines before, you know that there is an incredible amount of siloxanes that build up on the rings, on the pistons. The engine will run. It'll sound great for about a month, and then you'll just totally burn out the engine. So it's not your typical burning of a typical natural gas. There's the siloxanes and some other weird things in here do cause problems. So most people do have an engine of some type, and the flare is a backup. And out here we see everything. So they have funny definitions for their stuff too. What's an enclosed combustor? What's an elevated? What's a steam-assisted, air-assisted, non-assisted? Most people want to have a non-assisted flare. But they're running off of a little blower, so the tip velocities are really, really interesting. So managing tip velocity and getting flames that blow out. If you ever want to talk about momentum flux ratio and the crosswind effects and blowing out pilots and things like that, it does happen in the landfill industry. There's just not enough gas at enough velocity to keep this thing moving. They put shrouds around their flares to help prevent the wind blowing out their flare. Interesting stuff. So last year, new landfill rules came out, NSPS XXX, which is a horrible designation. I don't know why they did that. Of all the NSPS labels in the world that they've skipped over the years, right? Why couldn't they have skipped this one? I don't get it. Somebody's just, I don't know. But it came out last summer, so some of you may have been involved with some of these implications and helping your clients figure out what to do or not to do. The thing is, this is their new word, a non-enclosed flare, an enclosed combustor, or a treatment system. Those are the three categories. And I'm sure the Zinc and the Zico guys are just totally frustrated at the world keeping up with whose definition. They just want to talk about flares, but you can't talk about them anymore. Every industry sector comes up with its own little lingo, and it's not necessarily consistent. By definition, an enclosed flare is the same thing as an enclosed combustor. So trying to come up with continuity in conversations has been hard. Here's the thing that really is the trigger for everybody in the landfill industry is this definition of modification. So here's another example, just like in JA for the refinery sector. When are you subject to the rule? We're going to cut that threshold really low, and we're going to get you into the program faster than you otherwise would want to be. That's exactly what municipal solid waste has done. All you got to do is increase in the permitted mass or volume, any increase in the permitted capacity, either horizontally or vertically. You expand the landfill, boom, you're now in. It's not the 50% modification, major capital, anything like that. That's all gone. Again, very low threshold. People modify their permits all the time. So it won't be long until this rule replaces W, more than likely. And then it gets all the really cool stuff. Municipal solid waste facilities have to comply with our favorite, 60.18. And that's almost the end of the story, right? Once you know what 60.18 says, it's now applicable at a little tiny landfill. Here's the other little things, a heat sensing device at the pilot light to indicate continuous presence. So that's written into the rule. And people are really madly frustrated over this because heat sensing device. Is infrared the little thing that we use? What about acoustic monitoring on the pilot? All of those other things that we try, now we're trying to use the word, well, infrared is kind of heat, right? Isn't that heat? We're looking at the heat signature, so we don't have to have a thermocouple, but, or equivalent, and we don't know what equivalent means anymore. So this is causing a little frustration. The device that records flow to and bypass of the flare. So that's a unique little thing too that we haven't seen anywhere else. The bypass of. So if you bypass the flare and go to someplace else on a different flow meter, you may have to have two. So the two most important things, temperature of the enclosed combustor and the flow. Don't you love my cool graphics? I thought that was, sorry. 1 hour repair window. Most people have a energy recovery engine, and the flare is the backup device. And what do you do if you don't have another backup device? So this is really causing people a lot of frustration. And why would you think the 1 hour window is tough? Have you been to a landfill lately? How many people work at that landfill? Yeah, there's usually nobody there. Nobody there. A lot of these are closed, and there's nobody there. So how the MSW guys are really frustrated over this 1 hour window thing. They don't even get noticed within the hour, let alone fixing it within the hour.
That's if you go to a secondary, or if you have that.
Yeah, it's the
Primary control device. So if your engine,
it's the final control device. So you can vent. Basically, this is atmospheric venting of methane for 1 hour. Yeah. So there is just like they are playing with our AP42 emission factors for refining, they're playing with the emission factors for landfills as well. You can well imagine there's whoever worked on this years ago did not take into consideration the wildly varying heating values for the waste streams, and I showed you those huge CO2 numbers that could be present. That really changes the numbers dramatically. A lot of people don't want to use their AP42 factors. They want to use Texas has a really good set of emission factors to use instead. So other states operators in other states are petitioning to use Texas factors instead of AP42. And that was it. See, I told you to be fast. Now you know all there is to know about landfill flares. Any questions on that? Was that interesting? Anybody find that at least helpful?
You're always interested.
Well,
I never thought about vacationing at a landfill before your presentation. I think I'd want to avoid the pool.
I don't want to do anything I'm not supposed to do, but oh. The little circle was thinking. I don't know what it was thinking about so hard.
One more. What did you do? That one.
This guy?
Yeah. There you go.
All right. All right. Moving fast. All right. Greenhouse gas. Now, this is something else that a lot of people who do the flare stuff don't realize the overlap. So I didn't want to dwell on this too long, but I got a feeling you're going to be asked these questions, if not already, because they're coming to us from other flare people at the plant. So I'm assuming that you guys as well, from time to time, will run into this. The same flow meter that's being used to estimate the greenhouse, the contribution to the flare is being used to help calculate your greenhouse gas report. And it's due here at the end of March. So every refinery, every everybody's doing their greenhouse gas reports here in March. So do I use my flow meter or don't I? Dum, dum, dum. That's the question. Of course, everybody knows about the rule. It came out in 2009. It's put in Part 98. There's an online system. You fill out the form electronically, send it in, and life is good. It's Not as simple as that, of course. 41 different sectors. Lots of people are putting stuff in. It's all due here by the end of March. And most companies have already designated somebody to be all over this. So I'm not going to explain what it is. However, Subpart W of the rule reports establishes the rules just for us, for the petroleum and natural gas industries, right? Anybody know the reference in the picture? How many MADs?
6.
4. It's a mad world. Spencer Tracy, remember this? It was a great movie. If you have not seen, it's a mad world. You need to see it. It's got a cast of everybody, right? Everybody's in the movie. It's hilarious. It's fun. It's good family fun. You'll enjoy it. But they're all looking for the grant for the big W, right? So, and I just thought it was poetic justice that the crazy mad world is linked with a mad rule that we all have a hard time figuring out. So basically, what's unique to us, though, is this the flares, right? We have to report our CO2, methane, N2O from flares and a whole bunch of other sources in the plant. In order to do that, they require flow meters. Everybody wants to have one flow meter. Let's do one flow meter that does everything. So let's not put in multiple flow meters, of course. And it's the onshore refineries and chemical plants, natural gas seems to make sense. It's the offshore that just went berserk. How many of you guys, does anybody deal with offshore outer continental shelf stuff? Wow, that's great. Then I can fly even faster, because that's where the heartache is. Naturally, everybody wants to get a true and accurate count for the greenhouse gas. It's the offshore. Offshore flares are awesome. If you guys, they have just really cool flares. These giant booms come off the rigs and extend way out so they don't torch off the entire platform. And some of them burn liquids, by the way. Some of them are liquid flares, so really awesome stuff for the pyromaniacs in the room. So what's interesting, though, here is who has jurisdiction? That's the bottom line question. And who is running the show for greenhouse gas offshore, and why do we care? So Part 78 says that Subpart W, we get to follow these Bureau of Ocean and Energy Management rules. They're in another subpart, so you get to play happy trails and find your way through all these massive regulations that don't make a whole lot of sense. And there's different procedures, whether you're under the BOEM's jurisdiction or not. We got drug into a couple of these really interesting conversations over the flow meter, obviously. What type of flow meter do I have to have? So the emission calculations all done in this little cool system. You just report them online. I'm going to move this really fast, sorry. You must report the emissions for onshore now from the flare stacks, all these different devices. These guys seem to be a little bit more well-defined. But for onshore natural gas, if a facility has installed a continuous flow meter on the flare, you get to use that flow meter. If all the flare gas is not measured, you can estimate it, and that's the miracle, right? Everybody in the world was afraid I got to put a flow meter on every single flare in the Gulf Coast. Or if you're onshore petroleum natural gas processing, there's no mandatory requirement in W for that flow meter. So that was the hip hooray. I don't have to have a flow meter. End of story, right? No, it gets more confusing. The other question was, do I have to have a composition analyzer to do all these Subpart W calculations for how much is CO2, how much is methane, all those kinds of things? And the answer, of course, is no. You can use calculations. If you don't have the continuous gas composition, you can use appropriate for everything else. So again, it can be based on calculations. That's the bottom line for onshore, offshore Subpart W. Here's an interesting thing. Everybody wants to know, I have this greenhouse gas calculation, and this is the magic number that we all wanted to hear, was what percent of the gas is combusted. So of the methane I'm sending to the flare, what number can I use? So most everybody at the beginning was scrambling because they didn't tell us. They tell you here where, describe what nu is in some equation at some bottom of some page. And I should have put the page number on where this is at. Nobody would know this otherwise. So it's just bizarre. But yes, you can use your 98%.
Are any of these flares assisted, or are they all unassisted?
Most of these are unassisted. Yeah, they're offshore. The offshore ones are usually unassisted or pressure assisted, right? Yeah, they don't have the extra steam. But I did like the hunting and pecking. So I give you the number right there so you don't have to go searching for it. There is, everything's online. I don't think that matters as much. But then it goes complicated. So yes, you can use calculations for flow. Yes, you can use calculations for your composition. Yes, you can use 98%. Easy, we're done. And then it gets complicated. If you are outer continental shelf, you have a different set of rules. And I never knew this, and I probably would never have known if somebody didn't ask us to go dig this out. But there's a little bit different rule. Minerals Management Service is a different organization. I guess they're in charge of outer continental shelf stuff, and there's a distance limitation. Anybody remember what it? I don't remember what it is. There's so many 3 nautical miles or something offshore. I forget where it kicks in. So the BOEM is close, and these guys are off farther. Anyway, the bottom line is they were concerned about all of this. They conducted their own analysis, and should they or should they not allow venting directly to atmosphere, or should they allow require flaring? Of course, they ended up with, you must flare. You're no longer allowed to vent directly to atmosphere, even in the outer continental shelf. And do you have to have a flow meter? And their answer was yes. So this was the big hiccup. So if you're offshore and you meet outer continental shelf, yes, you must have a flow meter if you're over 2,000 barrels per day. So those of you in the flow meter market, now you know who your customers are.
There's a couple of reasons for that. One is royalties. You're supposed to be paying royalties for what you extract, even at.
Right. So good point. It's the same story on tribal lands, right? So the same story on tribal lands. There's a royalty for everything that comes out of the ground, and if it's not in the pipeline and lost and flared, they don't want to. They get to charge you a penalty for that, because that's their inducement for you not to be flaring.
Which is why they like to vent it, because then you can't see it.
You wouldn't otherwise have known. Anyway, so I provide all the citations for here if you ever get in the wonderful world of figuring out the flow meter thing. All right, that was fast and painless too. See, moving right along. Any questions? We're touching on a whole bunch of different topics that I know are not normal, but I wanted all the experts in the room to know. Oh, look, my glasses. You're good? Oh, yes. You may have the mic. Anybody got a watch that knows what time the next break is?
3 o'clock. We have. Okay. I will probably be getting through half to maybe more than half of JA before we break. All right, so we got our new fledged rule. We talked about J, and I basically said, don't worry about J, because we're going to go on to JA. So we're going to talk about the rule, and one of the things we wanted to spend a little bit of time on was, API submitted a bunch of comments to EPA to basically say, you gave us a rule, and we have a bunch of problems with that rule. So we were hoping for some answers, and we will go over the few answers that they did give us. They didn't want to answer everything. And then we'll go into some of these amps that we see that a lot of facilities are going to need to get in order to comply with the rule. Just some of the highlights, same as any NSPS, especially JA is only refineries again. So, it doesn't apply to the chemical sector, but we like to say, pay attention just because, you start to see a lot of similarities between all these different rules, and you may start to pick up on certain themes of what they like to do. One of the big things that when JA got finalized was it now made the flare its own affected facility. You know, before it was tucked under fuel gas combustion devices, now they pulled it out and said the flare is it. And then because everybody had that nice little ability to say what's a flare, what's not a flare, we didn't modify our flare, they basically said, well, we're going to specifically define what a flare is, and then we're going to make the modification trigger so tiny that basically every flare will come in. So that's where you got basically the part is like the flare gas header system now. And what's a modification? Well, adding a single connection to your flare is a modification. So you put one sample station in that does its purge to the flare, welcome to JA. So I mean, it's definitely was written in a way to get everybody involved. One of the things was it has its own monitoring requirements. A lot of the ones were things that started out in the HRVOC rules. So I mean, at least we had some monitors to think about. But one of the big things is, again, NSPS. We're talking about criteria pollutants. This is focused around sulfur emissions from the flare. So there's none of the talk yet of combustion efficiency or dynamic control. It's still more of a just let's reduce the amount of SO2 emissions. So they have these are just kind of the major things. And you know, when the rule came out, and you can see up, you say, what's the big deal? Just put on a flow meter and a sulfur monitor. Well, that's why we're going to talk probably for most of tomorrow about the difficulties around putting in a flow meter and a sulfur monitor. So this was not as simple as people thought. You know, we had in the other ones, you have to have a plan. You got a rule, got to have a plan. Let's write down what we got on our flare, how our flare is going to operate, and this one comes with some nice minimization alternatives. This one actually wanted you to do an assessment to try to see, can you pull material away from your flares? Then keeping in the same style of a lot of the consent decrees, it has a root cause analysis threshold that will trigger you to now figure out, okay, we had an event, we busted through our thresholds, we went to the flare, now go and say, okay, why did you go there? Is it preventable? Can you do anything to fix it so you won't go to the flare again? So I mean, there was this kind of continuing progress in the rule. And then it has a corrective action analysis that goes along with that root cause analysis. The two thresholds for the root cause analysis, the big one is the 500 pounds of SO2 in any 24-hour period. And also there was a flow threshold. Now this wasn't a flow limit. Remember, in California, they have a hard flow limit. You know, consent decrees, hard flow limit. JA does not have a hard flow limit because you're allowed to set this concept of a baseline. So you get 500,000 scuff per day above your baseline. So there's no hard cap. And that, you know, was a good thing because no flare is the same and no refinery is the same. I mean, everybody's systems are set up to send different amounts of material to the flare. So, I mean, it was good that they allowed that kind of variability. There's various different alternatives to the monitoring just based on specific cases. Yeah, just different exemptions for the root cause analyses. So the flow meter, again, it was that simple thing of put in a flow meter. One of the biggest things is must be maintainable online. You know, they thought about the fact that, you know what, if you need to go work on something you have to pull something out of a flare header, sometimes people don't like the flare to be operating when that happens. So they wanted to make it so if you had a flow meter there, you have to be able to retract those without shutting down the flare. So, I mean, they wrote that into the rule, and that has been able to be done. You got your standard, you know, you're correcting for pressure and temperature. That's pretty much standard across all the flaring issues. One of the things they added there was a quarterly visual inspection of the flow meter, and that's of the wires, the connectors, to make sure nothing's being, broken or frayed, So, I mean, they have that in there, but they put an out. If you have redundant transducers, you don't have to do the quarterly verification. So, I mean, you can, if you want to put in 2 sets, or if we'll talk tomorrow about the dual transducer possibilities, you can get out of that, though you may want to look at them anyway on a quarterly basis. And then there's the requirement to, and again, the JA, they use the word with an ultrasonic flow meter of recalibrate. There's nothing to recalibrate. So it's hopefully nobody likes, and we all love rules when it comes to, or words when it comes to flares, and this will probably become an issue at some point. But you need to do it's the flow verification. They say biannually, unless otherwise specified by the manufacturer. Pretty much every manufacturer is an annual basis. So at least once a year, somebody's coming out and pulling those transducers out of the flare.
When you said this several times. When you say that there's nothing to recalibrate on these ultrasonics,
Mm-hmm.
do you assume that they're just inherently accurate?
It's one of those things. It's not an accuracy. It's are they working or not? I mean, it's all solid state. It's all electronics. There's nothing to tweak on them. So I mean, when even GE comes out to do their fluid,
what they do when they come.
they pull out the transducers, make sure they're not covered in gunk, and they basically have a zero flow cell. And they put the transducers in there, measure the zero velocity, run a bunch of diagnostics. And as long as those diagnostic parameters are close enough to when they left the factory, then they say, okay, they put them back in the flare header, run some more diagnostics, again, close enough, you're good to go. There's no flow, they're not testing them against flow at any point.
You still have these just radically screwy results from these ultrasonics.
Oh yes, I mean.
So something isn't working.
Yeah,
I don't know what it is.
Come to the talk Wednesday.
Oh yeah.
Yes.
I'll be there.
Yes, and tomorrow we're going to talk a lot about this, but it's just one of these things that how the technology was developed and designed wasn't, well, it's good on flare gas, it's not perfect on flare gas.
So if they don't work, there's absolutely nothing you can do about it.
So you replace it.
Yeah, well, there's always a new model.
You can upgrade the sensor.
Upgrade.
Say what?
And obsolete.
Can you say that again?
test the flow meters?
No, they're not a SEMS. So
There is examples where you have to rata test flow meters. There is a performance.
You can do a performance test on a flow meter. And the same way you do a test if you have a CERMS rata for an FCC, where you might have an anti-bar measuring the flow.
Yeah.
You can test that against standard method, reference method 1 through 4, whatever, and you'll get a number that tells you how accurate that flow sensor is. But nobody's going to take the time to do that in a flare unless they're crazy. And it's not required by the regulation.
Yeah, no, they didn't put the requirement in for any rata testing. But then, of course, you need this all for your 500,000 scuff above your baseline. Everybody, first thing when you get a new rule, the first thing you look for are the exemptions. Because, if you can get out of something, why do it? So with flow meters, pretty much the only time they put in flow exemptions for monitoring was the emergency flares, secondary flares, and flares designed with the flare gas to capture all routine flows. And there's one thing in all those definitions that's the common factor, and that is you have a water seal. If you don't have a water seal, by the rule, now we can talk about amps, but by the rule, you have to put in a flow meter. So there's no other exemptions out of that flow monitoring requirement.
Have a water seal, does the flow meter have to go upstream or downstream of the water?
They don't specify. Each one has its issues. Generally, if it's downstream of the water seal, hopefully it can see your purge gas. You know, if it's a big pipe and the purge gas isn't that high of a flow, I doubt you're going to be able to see it. So I don't know what it would show. If you're upstream of a water seal and if you got flare gas recovery, I mean, there's likely you're going to see a wave of differing numbers all over the place as the gas is going by, coming back. You know, there's going to be all kinds of odd numbers in there. But I think any time you have a water seal, you have to have additional monitoring. Even though it's not required, I think you need to have additional monitoring on water level, pressure in the header, so you can actually say when is material going through the water seal to the flare. So you can say that data is actually real, and just the rest you can chuck, because otherwise you're gonna have a huge headache. You know, we even saw with you know, some of the when you're trying to put in control strategies is when you all of a sudden your flow meter's reading 0, but you're like, it should never read 0. There's always a purge gas going through there. And so you see people putting in that hard minimum of there's a purge gas flow, so regardless, we have that flow. So it's not perfect, and but I think right now it's the best we got. So it's kind of, and it doesn't even meet the requirements of the rule. So that's where it's even better, is that the best technology out there still cannot meet all the requirements of the rule. So it's just where we're at, which is where amps will come in. One of the big things on with some of these exemptions is you can only bust through your water seal 4 or fewer times in 365 days. So it's not like, okay, I have a water seal, but it's continuously bubbling through. I have that water seal. No, they put a breakthrough requirement for that. And the, well, I'll talk about it later because it should be later. Okay, the other thing that, other than these root cause thresholds that the rule had, was an operational limit. And that was the 162 ppm by volume on a dry basis of H2S in your gases going to your flare. So, I mean, that is, again, that was a big issue when it came to flare gas, because you know, a lot of people don't operate that low, especially if you're running a nice sour crude. So there was going to be, you know, when people started thinking about, you know, how are we going to comply with this rule, this number was sometimes the hardest part of it, because how do you get below that? You know, it's either you can find a way to get those streams out of the flare, or you have to find a way to treat the flare gas or recover the flare gas to treat it. So I mean, this sulfur limit pushed a lot of people towards flare gas recovery, where they maybe wouldn't have done it on a flow basis alone. One of the big things is this the SO2 emissions is 500 pounds on an absolute basis. One of the times to think about that is if you have an interconnected flare system that is considered a single flare. So now instead of having 500 pounds go out one flare and 500 pounds going out another flare, if they're interconnected, it's 500 pounds total. So I mean, you have you can't think of them as different flares anymore. You have to think of it as one flare system. When we get into the monitoring for these two things, you know, based on what we've seen from the technology so far, it's not as easy to use one technology for both, for the root cause analysis and the H2S limit. They have different spans, and so it's kind of easiest in your mind if you kind of keep them separate, and you'll be able to keep in compliance with each one. So for the H2S analyzer, on that low span to comply with the 162 ppm, that has a span requirement of 300 ppm. So that's, you know, that's pretty typical. That's what you had for J. That's typical of what's in the consent decrees, or around 320 sometimes, for a nice annoying reason for those facilities now that have a consent decree that says span to 320 and a rule that says 300. So they're going to have fun with that. And so, you know, you have that requirement. You need to have a QA/QC manual for Appendix B and F. and there is a compliance demonstration for that limit. For the RCA requirement, EPA gave you a couple of different ways to comply with the rule. I still can't say whether or not that hurt or helped things. I think it almost caused more confusion. But it gave us options. So you can either do total reduced sulfur monitoring, which if they don't define total reduced sulfur in the rule. Yeah. No, the rule defines reduced sulfur, but does not define total reduced sulfur.
Okay, just like reduced sulfur or total sulfur.
Yeah, it doesn't say total sulfur anywhere. It's always the total reduced sulfur. But the only place that total reduced sulfur is defined is method, is it 15?
15A.
Yeah, so in 15A, it actually defines total reduced sulfur, and those lists don't mesh with the definition of reduced sulfur. So there's some even more confusion around that.
It becomes a little clearer if you read the preamble.
Yeah,
The preamble has a discussion about the fact that reduced sulfur and total reduced sulfur, and there is no method. They wanted a total sulfur number, so they wanted, but there is no method, reference method for total sulfur. But there is method 15A, which is a total reduced sulfur method that will be positively biased if there's any other sulfur species present besides H2S, COS, and CS2, which means you'll see whatever's there. It's a total oxidation method, right? So you'll see what's there. You will get a total sulfur number. It's a de facto total sulfur number, and that's what they said. They said, but we're saying it's TRS because we can't say it should be total sulfur because there is no total sulfur method. So we're just going to say use 15A. We're going to call it total reduced sulfur, but it is a de facto total sulfur method.
Yeah, good point. They also gave us the option of using the H2S monitor. But again, because they are looking at the total sulfur is the number they want, you now have to develop a correlation, but from your H2S measurement to your total sulfur measurement. So that involves a lot of correlation sampling, the 10-day initial event plus once a week. Get too far out of your measurement, you're doing another 10-day sampling event. There are facilities that did go down this route, but most people, once they start saying we have to do how many samples, they say no. My favorite phrase is we're not good at getting samples, and so they basically just said no, we're going to skip that. And then they did throw out this SO2 monitor option. There are very few refineries that this is even possible at. I think we've only seen one. And that is where basically any gas that would go to the flare would also come from the fuel gas network, which is already being monitored. That's going to, that gas in the fuel mix drum is going to a boiler or a heater that already has an SO2 SEMS on it. So then you can back calculate from the SO2 SEMS what was in the fuel gas that then went to the flare. But if you have any other entry points into that flare system, you can't use that method because that gas won't be the same gas as that was seen by the SEMS. So they put it in there, but it's almost impossible to use. Okay, for the RCA method and the TRS monitoring, here they put in the span value. They didn't give you the nice number of 300, so everybody can know what number it is. They decided to say, okay, it's got to be 1.1 to 1.3 times your maximum anticipated value. So basically what they did with this span requirement is they took away your ability to have a meter that is pegged out. You must always be able to measure what's in your gas. You cannot say, well, the monitor was pegged out, we guess it's about here. That's no longer allowed. But then they did set a lower boundary. So I mean, even if you say, well, we're never going to get higher than 0.5%, you still have to span that upper range at 5,000 ppm, which is still, when you start thinking about your cylinder gases, that is still very toxic. So I mean, these cylinder gas issues are really causing a lot of concern and rightly so at facilities. And tomorrow, we have somebody from Air Liquide who's going to be coming and giving a short presentation here about that calibration gas issue. You can use a dual range monitor. They did allow that. So like one of the technologies we talk a lot about with the total reduced sulfur, total sulfur method is the thermoscientific, the SOLA 2. That's again the pyrolysis technique, burns everything, the SO2 monitors SO2. They said, yes, that device does have the ability for 2 ranges built into it. And so they said you could use that device for the 162 H2S limit. However, you now have a 162 total sulfur limit, not just H2S. So if you have a lot of these other cats and dogs, the sulfur species in your flare system, you now have an artificially lower sulfur threshold, so or an H2S limit. So a lot of facilities weren't very comfortable with doing that. So most people have gone with a way to measure H2S. All about the same. Okay, that was the same. Yeah, so here was that whole thing. Here's the citation for that where it says the concentration by the instrument is the numeric concentration for the 162. If you, yep.
On the PRS analyzer, how do you RADA test it? People RADA test those analyzers?
Well, when the RADA test, if you have the sample parts, and you can have a testing company come out there, they are going to basically bring out a SOLA 2 to test. The reference method for the RADA is the total sulfur method. So you'll be going up against that SOLA 2, or that pyrolysis technique. So I mean, you can, if you have the ports, you can do that. There's a bunch of other issues with RADA testing as to whether or not you're at 50% of maximum or normal load and all those good things that come up.
The question is the device that they use or the gases that they use?
They give you 2 options.
But I thought
You do a RADA test.
Right.
And the reference method is 15.
Which is for sulfur.
It's for what?
Sulfur.
It's effectively, as I said earlier, de facto total sulfur analysis. It's like pyrolysis tube analysis.
But the people I've talked to say is that it's written for low BTU gases, and if you test it using high BTU gases, there's safety issues where you have to combust it all, and so you can't follow that method on a flare gas system.
Well, the other option you have is to use the Section 16 requirements of PSP, which is basically a glorified CGA. Slightly more data handling requirements. I haven't looked at that closely, but I'm going to have to because that's the option.
That's what I was kind of looking for. For those with FGR, it's in there. It's whether or not you receive routine flow or not. And then you're allowed to use the alternative relative accuracy method, which is a glorified CGA, is what you're saying.
Yeah.
Yep.
And it does, it is only for those flares that do not receive routine flow.
Right.
You have that option.
But that's going to change with that Max CC was proposed to take away that routine flow out of that exemption.
Well, most people are going to go flare gas recovery anyway. Basically what this is driving you to.
Yeah.
So are any people even doing a RADA? I would be of the opinion that most people are not doing a RADA, right? They're just going to do the CGAs.
Right, and that's what I've seen too.
Because nobody wants to bring in the instruments. Most people will challenge it with a gas.
Yeah. And I can say that it's difficult to do a RADA test on a flare if your concentration are changing. Now, for most flares, you got flare gas recovery, your concentration is going to be very low, single-digit ppm anyway. But we had one flare that we had to test for consent-free purposes, where we did not have flare gas recovery on this. The routine concentrations ran 1,500 to 2,000 ppm H2S, but the flow was nothing. And so we asked EPA if we could have a variance from the requirement to meet the 160 ppm standard. And we suggested that, look, as long as we can stay below 500 pounds of SO2 emissions, would you be willing to accept that as an alternate means of demonstrating compliance with J, and they agreed. So we had to go rapid test the analyzer we put on that flare. And the biggest problem we had was trying to sync the timing of the injections on the analyzer, because we were using a GC to test, testing company using a GC to test against our GC, and we tried using a 10-bar bag and taking a 21-minute bag sample and run it on their GC. That didn't work. We actually, I talked with Foster Curtis at Sherry Park to get that approved as a variation of the standard method. We ended up just having to set the trailer right next to the SIMS, and so he could look at the front panel and see when our SIMS injected, then he would push the button on his GC, and we got them to sync up, and they actually were pretty good. We passed our test that way. So it's, but for most people, it's not going to be an issue because you're not going to have any significant amount of H2S in there. It's not going to be changing. It's going to be very low levels and not changing much. Ours was kind of a unique situation. But rad testing for flare, I wouldn't recommend it to anybody.
Mm-hmm.
You're better to do the CDA if you don't have routine flow.
Yeah, which gets back just to the whole point of a lot of these test methods and for RADA requirements and other things, they were all written for things like boilers, you know, heaters, something that's running at a nice steady rate with a nice consistent fuel supply, so you can get these measurements to know how it's performing. The flare system is anything but. So I mean, that's the problems I think we see most people dealing with is how do we force fit these methods that were designed for equipment that doesn't work at all, like what it's on. And I think that's going to be a lot of the challenges. Okay, I already touched on so you can also, with your H2S monitor for your RCA, biggest difference was the 10-day sampling and continual weekly sampling with, if you're out of the 95% confidence, you're going to have to do another 10-day event. We like to, you know, people start talking about this, and especially like if you have a water seal, was, okay, where do you take that sample? Are you taking that sample upstream of the drum, where you're going to get, you know, the varying concentrations, or do you take it downstream of the water seal, where you might be sampling purge gas all the time? You know, so, you know, there's pros and cons to each one. One thing that, you know, came up was, okay, well, we'll just test the natural gas purge all the time, and, you know, we'll get the same thing. We'll get a nice, there's probably only H2S in there, if at all. So it'll give us a nice, it'll give you a 1-to-1 correlation of H2S to total sulfur. Well, then, are you under-reporting emissions if you had a lot of CS2 that came out with your flaring event? So, I mean, there is a kind of a risk in there of you may be under-reporting SO2 emissions. So that's something that nobody wants to be charged with. So if it's upstream of the water seal, how are you going to get a correlation that's going to stick every week, you know, based off your 10-day event if it's going to be wildly fluctuating? So there you're pretty much into, I'm going to be doing my 10-day correlation sampling every day. So I mean, it's you know, it's a tough situation to be in, which again gets people thinking, why would I go this route? Again, save yourself the headache and go with the total sulfur monitor. We talked about this one. So when we saw everybody looking for that optimal configuration, the ones who had probably the easiest, well, I'm not going to say easiest, but I mean the most straightforward time was people who already had a GC there for H2S because of J. They already had a GC there, they were measuring H2S, it spanned correctly, and now they have this RCA requirements, and then they decided, okay, I'll add on something like a SOLA 2. You know, that was pretty straightforward decisions. It's all the ones that didn't have something that now are into this decision of where do we want to go? Can we do it with one analyzer, or do we have to have two? That seemed to be, because, you know, the price tag of these things are not inconsequential, but, you know, you know, people wanted to, of course, save as much as they could. So there was a lot of people going around and around on all these issues and everybody chose everything. That was the one thing, is like everybody didn't settle on one game plan. It was everybody went in a ton of different directions. So it'll be interesting to see in a year or two, yeah, are people sticking with what they had, or are they going in and redoing their systems? Same with, as we showed in for NSPSJ, you have the exemptions for the inherently low sulfur gas streams. So, you know, these are pretty straightforward. Basically, if there's not going to be H2S in the flare, you don't have to monitor for that. So a little sanity. You know, and also you have again these exemptions for the flares that have the water seals. And so in that case, you don't have to do the monitoring, but you have to do the monitoring on the water seal to be able to tell you when did you break through that water seal. Water level indication and pressure in the header. So you know, basically once the pressure in the header has exceeded the pressure by the water seal, that's considered an event, and then you know when you have to estimate your sulfur emissions. This was a point that came up that was kind of interesting, was tank cleaning and using a temporary flare to collect the emissions coming from degassing and cleaning your tanks. And it came up because I was at a facility and they were asking us about, they generally used portable thermal oxidizers. And the thermal somebody who was doing their marketing correctly went and said, oh, here, use our thermal oxidizers because we got an amp for our thermal oxidizers so you don't have to do the sulfur monitoring. And they just said, we have to do sulfur monitoring? And it turns out that yes, it is a fuel combustion device. And so we was like, okay, well, if the TO needs an amp, well then if you have a flare, do you need an amp for that temporary flare? And no, it's a little different. They actually said that you need an FMP for that temporary flare. Because for a tank, when you're doing the degassing and cleaning of that, that's considered process upset gas. So it's not subject to the 162 requirement, but you have to have the procedures in your FMP that document how you've minimized those emissions. So you can go with a flare, but you got to have an FMP for it. You can go with a thermal oxidizer, but you got to have an amp for that thermal oxidizer. Or there is a exemption in the rule that if you capture those gases and treat them in an engine, then you're exempt, automatically exempt from everything. And the one thing that we were like, why is that the case? And the rationale was because the engine makes useful work. So you could capture that energy and use it somewhere else. But the best thing is, there's no requirement to hook that generator up to anything. So you can just get your generator out there, and it's not like you're not using more gas, because obviously the gas coming off your tank cleaning is not going to be a nice BTU value, so you're going to have to supplement anyway to keep that engine running. So it's pretty much, they put this nonsensical exemption in there that really you can, so basically use an engine, don't hook it up to anything, and just burn it all out. That's right, that's right. So, but it just came out of one of those things of thinking about this non-routine, you know, tank cleaning that happens, and you think of it as a temporary flare. It's temporary, I shouldn't have to do anything, but yet they anticipated for it to be a covered process.
But it has to be a generator, it has to be able to generate electricity?
It was, yes, it was a generator. Yeah, because they had to create useful work.
It has to be portable for some reason.
Yes.
Well, then that's probably a pretty good stopping point. I got.
Oh, okay, yes, we have a break. Continuing on, we have the FMP. You got to have your plan. So, I mean, the first, we kind of think of the FMP as in two parts. The first part is the straightforward part. It's what's the equipment you have, what are the gases going to it, how are you measuring it, how are you monitoring it, all that kind of stuff. The hard part is the minimization assessment. This was where the real work is. And it's basically going through your processes and looking at each connection that's going to the flare header and understanding why our gas is going to your flare header, and can that be stopped? So, or redirected elsewhere. So, I mean, there was a, that's a larger hurdle. And, but one of the things that we've done a lot of these assessments for people, and one of the things we realized is for like you have, around the order of 1,000, maybe more, connections to your header, is finding the ones, some of the ones, it's easier to figure out why you can't minimize than why you can minimize. And it's being able to document that. Because there are some things that you can't minimize. I mean, there's a reason why they're there. It's for how things function. And to try to engineer around that will be extremely cost prohibitive. So, I mean, it is, but being able to document that you can do that is the big issue. So when you're looking at the minimization assessment, the rule gave you these things that you need to look at. So I mean, you got to look at source reductions. You have to consider flare gas recovery. You don't have to install it, but you have to consider it. And if you are fuel gas long as a facility, if you have to look at flare gas recovery. And it's not, people say, well, I'm long. Why would I want to recover any gas? Well, you also have to consider installing cogen along with that to use that gas. So, I mean, it's even worse if you're fuel gas long. And then the other one is the minimization of the sweep and purge gases. And this is just one of those things, and I'll talk about it on Thursday. It's just one of those gases that, since it's always going to the flare, you just want to make sure that those are down at the minimum rates. And then you're going to take into account, the basic, is it economically feasible? Is it technically feasible? All these different things, just to, kind of say, there's a gut check of, is this something we should put money into or not? If you have flare gas recovery, there's some additional things that you have to document. You're going to have a water seal, so I mean, you're going to have the ranges for your monitoring on that. One of the things that we've seen with facilities that do have flare gas recovery that maybe is there, sometimes isn't there, is you need to have a way to monitor and quantify that amount of gas that is being recovered. Sometimes people say, well, it's being recovered. I don't care how much it is. I'm recovering it. But the rule wants you to tell them how much you're recovering. And then the other thing is for the compressors, is there's a lot of words that you have to put into the plan around like compressor staging. That's another issue that kind of like how long is it, if you have multiple compressors and you're running with one and the flow gets high enough where you need the second one, how much time does it take you to start up and get that second compressor running? So, it's kind of one of those things, like you're taking this plan, you're going to be submitting this plan to the EPA, is what's the time do you put in there? I mean, we talk to some people and they're like, oh, well, it takes us a couple minutes. You don't want to put that in the plan because that's what you're going to be held to. So if you can't start up that second compressor within a couple minutes, now you're not in that window that you put in the flare gas management plan. So, I mean, it's a, take into account, what happens if it doesn't start up right away. If you had to try to go through the startup sequence of that compressor a few times, how long is that going to be? We saw in one of the, I want to say it was Shell's consent decree, they had in there an hour to start up that second compressor. So, I mean, part of us say, why would anybody say another number? If the EPA's already allowed somebody an hour in between starting up that second compressor, why would you ever say less? So, I mean, things to think about.
You may be able to justify more if you have a good reason.
Exactly. So, I mean, you have to look at your system and how your system works and just be able to document that rationale. I think a lot of the minimization is a documentation of how your system works, because each one's different. Oh, sorry. The plan, it has a few, it doesn't ask for a ton of drawings, it asks for a few drawings. One of the drawings, this is probably the only P&ID type drawing that needs to be in there. They asked for the flare tip drawings. I hope they're going to have fun with them. I don't know what they need that for, but you know, of course the flare tip drawing has lots of information, so I'm sure that it's going to be some poor intern's job one summer to take all these flare management plans, look at the flare tip drawing, and make a spreadsheet documenting the information that's on them. So who knows what they will do with that in the future, but you know it's in the future. All the rest of the drawings that they require are process flow diagrams. And these are ones that we definitely say, don't give them P&IDs. Don't give them more information than they ask for. You know, give them what we like to call our cartoon drawings. You know, give them those pieces of information that they specifically ask for, but don't give them information that they can start to make other judgments on and get other information from. Plus, most people then you get into those drawings are going to have to be CBI probably, and you're going to have to be dealing with 2 versions of your flare management plan. Just skip that step and do some cartoon drawings. So you have one, this is one that's just showing an interconnected system and showing the different process units and the way the system is all connected up. The next PFD that they asked for is just one focused around the flare itself, like showing how's the steam supplied to the flare, what's your monitoring on the flare, you know, pilot gas, different, if your knockout drum, water seal, those type of things need to also be documented. But again, use the cartoon drawing, not the P&IDs. So, I mean, this was kind of a new thing for the rule, was the minimization assessment. And when we started talking to facilities about how to do this, and really the biggest thing was, you know, you can say, oh yeah, you know, we did this process and we did this, but the rule asks you to give them a list of all the connections on your flare header. And then it's like, well, how do you know that or how can you show somebody that you did look at minimization from all the connections? So I mean, that's going to take, so we went through and basically developed a system where we take all of your P&IDs and we find all the connections to the flare header. We highlight them and then we put them into I want to show into a spreadsheet, and we document, you know, what drawing is it from, what's the connection ID, and then what's the reason for using that connection. And that's where we would go and have interviews at the sites. We would go talk to the operations, and these guys know everything. It's amazing. I'm amazed every single time I do it. We'll go through every single P&ID, and the operator on every single page will be like, yeah, that's the valve that's over by that ladder, and yeah, no, I haven't touched it in 5 years. And you're like, okay. He can visualize in his head every single connection in that unit. And so we'll talk through with those operators and say, you know, when do you use this? You know, is it only during maintenance? Is it only during a startup or shutdown? You know, is this, you know, is it when you're getting too high of a pressure in a vessel and you need to bleed some non-condensables off? You know, how often do you do that? And it's kind of figuring out the whys. You know, you have those connections, is now the why do you use them? It's looking at control valves. We do a lot of getting the data out of control valves for like the percent open, to then trend that and say, well, is this a control valve that opens, you know, once every 6 months and it lines up and usually with an upset? You know, so it's more acting in an emergency capacity, or is it something that's riding on the flare header all the time? So, you know, it's going through and kind of being able to do that assessment of the connections. Let me see here. Okay. So then when you've done your identification and then so maybe you found some vessels you know, that you think would be good opportunities for minimization. Usually you're looking at the high BTU streams. Is there a stream that would be good to do something else with? I mean, it's like, you know, if you have a stream that's like mostly nitrogen, obviously you don't want to be routing that to your fuel gas network. That's not helping you out. But if you have some good BTUs there, that's something to look for. Another thing to look for is high H2S streams. If you have some high H2S streams that are going to your flare, look for ways to get rid of those first. Last thing you want to do is remove a bunch of low sulfur, high volume streams from your flare. Because remember, you're on a 162 ppm concentration limit. Don't create a concentration problem where there isn't one. Get the H2S out first, then go after flow. This is just an example of some different facilities have different levels of flare header drawings. This is a good one that we've seen. Don't try reading it, it's in Italian. So it's, we actually got to go do a minimization project on a ethylene cracker in Italy. It's real cool. But, say what?
We had good wine.
Good wine, yes, yes. And spent 2 weeks out there. It was lovely, but they had this type of detailed drawing where it doesn't tell you much about that connection, but it has on the header every connection, even down from the little sample building and the sweep point. So I mean, it just is a way for you to visualize where everything's coming and to show where all the connections are. Couple of the big things to think about with your minimization assessment. One of them is your PSVs. Now, while that, you know, the H2S from those leakages are not subject to the 162 requirement, how you're going to prove that your exceedance of 162 is due to leakage is going to be a challenge. So going after leakage is something to think about. You definitely want to document how you are minimizing leakage from PSVs. You know, most of you have, there's OSHA requirements for, you know, inspection of PSVs. Document that. Or if, say, a PSV opens and closes, do you have a procedure to go back and check to make sure that valve reseated properly? Many times people are like, yeah, we'll go by, and then, you know, maybe shoot it with a temperature gun. We ask, is there a procedure for that? No. It's just something, yeah, do you do that all the time? Well, probably most of the time. But it's kind of like more formalizing that procedure. One of the things also that you can do for especially if you're looking for a high H2S leakers is there's an acoustic technique. There's the picture of the VPAC 2. It uses, not ultrasonics, but sonic detection to basically hear that turbulent flow of gas sneaking by the PSV. So you can find your leakers with that device. One thing we've heard from people is don't just do it on the PSV. Look at the bypass valve too, because a lot of times you'll change out that PSV every couple of years. Nobody ever touches that bypass valve, and suddenly that's the one that's leaking. And so it's good to check those as well. The other concept that the minimization talks about and with your baselines is this concept of alternative baselines. So you're going to have your normal baseline for normal process flow, but if you have some condition where you're going to be sending a larger quantity of gas to your flare on a fairly routine basis, is that you're allowed to document that and you're allowed to put in an alternative baseline. Because basically, if say you're doing a regen on a vessel, you don't want to have to do an RCA to say we were doing a regen on the vessel. Everybody knows that. So you get the alternative baseline for that event, and that's going to save you doing RCAs for it. Looking at startup and shutdown, usually around maintenance. Minimization is all focused around if you want to get out of doing an RCA event, have written procedures to document how that startup and shutdown are done, incorporating minimization. If you follow that written plan, and I keep saying written for a reason, is if you follow those and you exceed your threshold during and is due to startup or shutdown, if you followed that plan, no RCA. If you didn't follow your plan, well then you got to do an RCA to show why you didn't follow your plan. So, follow your plan. But it's going to, and one of those things is people ask us, do we have to do this written plan in all of our startup and shutdown plans? Well, no, because this is to get out of an RCA. So if the event is going to go through a threshold, then yes, go through, prioritize those, put in the written plan, and go about your day. Because if you're just doing maintenance on a pump, you're not going to trigger an RCA because of that. So why go to the time to get written procedures in there? And then you're also going to have to talk about if you have recovery compressors, talking about the, minimizing when the compressors are down. How are you minimizing the gas going to the flare when your compressors are down? Okay, so the baseline flow determination. One thing, though, is this is supposed to be determined after you've done your minimization assessment. So you're supposed to have gone through and found all the places where you can minimize flow, and then you're supposed to set your baseline. You're not supposed to set a baseline and then figure out where you can minimize stuff. It doesn't have to include pilot or purge gas, but it can. Especially, it doesn't have to include the purge gas if it's consistent. If you have a variable purge gas, then yes, you're going to want to put that in your baseline. We recommend at least 6 months of data. Some people are going to have that, some people aren't. We know some facilities who their flow meters are going in October. The deadline is November. So they're not going to have a lot of data to do their baseline with. We generally recommend the 6 months just because a lot of facilities have a seasonal variation. Things are warmer in the summer, generates more off gas. You might want to have either an alternative baseline or set your baseline to summer conditions. So here I'll just run through real quick a couple of examples. This is actually real data. So we got the data from the flow meter. Because they had a flow meter. So what we do is we plot it up. Here's the average. And so we said, okay, with this average, am I missing numbers? We are looking at about 1,000 scuff per hour as a baseline. But this also includes things like this event, which is almost obviously an emergency, and the BSO told us that this was the emergency, and then some other emergency in conditions here. So we say, when you're setting your baseline, there's no procedure in the rule to tell you how to do this. All they said was has to be reasonable. So we said, okay, if we're going to be reasonable, we shouldn't include an emergency event in our baseline. So we went through and said, okay, we're going to say what's 2 standard deviations above the average, and then we're going to get rid of the data that's above that. So then this is the data where we've taken out the ones that are greater than 2 standard deviations, and now taken the average again. And we're looking at about 3,000 cubic feet per hour.
What's the unit of X scale? Is it per day or hour? Trying to get a feel of how long this duration is.
This was over a year's of data. Yeah.
So the typical year they'll have 20.
So really, if you look at this data, it kind of shows you that typically this flare runs with just a pretty consistent level of minimal flaring, and then because this was around that really big spike, so they were having some upsets that they were having some issues with, and then this was also at that tail end where I believe they were having some startups.
But in the normal sections there, I still see 10 little tiny spikes just barely above the.
Yeah.
What's the consequence of operating above that?
I mean, it's just you just got to know it's flare data. I mean, it's not going to be nice, smooth data. It's going to be all over. No deviation or anything like that. Yeah. You were looking for the root cause analysis threshold to cause you to do an RCA. is 500,000 above this number that you said, that just has to be reasonable
Is there in a 24-hour period?
in a 24.
So that's even more flow.
Mm-hmm.
But what's the, is there a required duration for baseline?
No.
See, that, you can see a potential problem there. This is the whole year. The middle section, if you happen to miss the both end of it, your baseline is going to be so low.
Yeah.
And that's so easy.
And that's when, this was when we did this for a facility, it was before, they had this flow meter in place before the rule was finalized. So they were collecting this data, and they were one of the few that had to submit their FMP within 60 days of the rule being finalized. So they didn't have time to go back and document, is this emergency, is this maintenance? They needed a way to get a baseline. So basically we said, we don't want to take out too much. Because everybody wants the biggest baseline they can get, because that's going to save them the most work. But we still got to be reasonable. So we said, and a refinery has, there's probably maintenance going on every single day on something. So is that now non-routine? If you're doing maintenance every single day, that kind of sounds like it's routine. So I mean, you kind of say, well, we want to include some level of maintenance in your baseline. So that's where we want to take out, yes, the huge event where you lost power. That one obviously is not routine. But you don't want to get so nitpicky that you're taking out every little blip just because otherwise you're going to get down to probably purge gas. And then you're going to be doing root cause analyses anytime you have a minor maintenance event. So it's, so yes, you want to include some of the bigger spikes, but not so big that you can't pass the red face test. So it's, so yeah, there's no clear guidance on this. Another way of looking, this is the same data. And so we went from here where we said we were about almost at 3,000 scuff per hour. Now we said, okay, what happens when we plot the data as a histogram? So we want to say, so this is just for each of these flow ranges, and this is 1,000 scuff per hour, how many data points did we have in between these fractions? To kind of see, was there another way to look at it to say, was there a clear break point as to, as to where we should set that baseline? So here, this is probably corresponding to mainly just probably purge conditions. And then you have, these are probably some of your more minor maintenance events. And so we started looking at it and we said, okay, what about, should we cut it here or here? Because it looks like it fell off pretty good where these are now starting to maybe get into that unreasonable level. And so we looked at, well, how many points are below the 2,000? And that was 68% of the data. And then we looked at the 3,000, and that was at 92% of the data. So we felt relatively confident that we could justify where a baseline of 3,000 scuff per hour would be reasonable for this facility. But again, we saw the data, and this data was pretty consistent for most of the year. So then we looked at another facility, and this is what their data looked like over the year. This is not the nice trend where you're thinking that, okay, we run at a pretty consistent rate. So we do the average again, take out the 2 standard deviations above, and it's still looking pretty all over the place. So again, we are looking at here an average of about 2.2. Then when we look at the histogram, again, this didn't have that nice little falling off that the other one had. So we have some of this base case. We have a lot more in this is 1 to 2. And then you start saying, well, should you break at 2? Should you break it at 3? Where is that point? And you're looking at the data, and so 66% of the data is in the below 2. But then when you look at 3, you're looking at 89%, but it's not as clear cut from the data as to where exactly you should put that baseline at. I'm trying to think. I don't remember exactly where we put that one. Yeah, it was like the first one we did. So
interesting to look at from a statistical perspective like you're doing there, but I think if you look at the previous slide and you go and look at what is causing the particular blips. You know.
Yeah, this was a flare that I think Troy brought up the issue where they had a hydrogen plant that was producing a lot more hydrogen than they needed. You know, they built the plant for expansion case, and they didn't have the expansion yet. So they had a lot of hydrogen that they were putting to their flare intentionally because they had nothing else to do with it.
Hydrogen should be part of the base case.
Yes. So I mean, if you look at these numbers, I mean, these are millions of scuff per day. So I mean, that's where we had much greater numbers, and so I mean, they ended up. I think it was somewhere around like 2.5 to 3 million scuff per day as their baseline.
Well, hydrogen is not waste gas.
They don't define waste gas. Yeah.
Only what?
In CDs. Yes. Right. Yes. The JA does not define waste gas. They only care about vent gas. They care about total flow. They don't care about what's in the flow.
So you can't subtract out the hydrogen.
No, you can't subtract any other hydrogen.
I might be able to look at this. If I operated this plant, I might be able to pick out 3 of those points as exceptional events. You know, true upsets where stuff broke. The other stuff was normal operation, and define my baseline that way. If I could pass the red-based test on that, right? I mean,
yeah.
Because it's open to us to defend our baseline.
Yes, and that's in the FMP. That's how we wrote up how we generated the data, how we did the process of removing data to show that we weren't putting everything in there. Especially since we had the high number, we also put in a lot of discussion around the hydrogen issue, and saying, you know, this is a kind of gas that is intentionally there, but you know they're going to not be doing that hopefully in the future.
I think there's a lot of creativity on the baseline because it was never specified how to do it. So eventually, once they all get nailed in December, we're probably going to tap into another getting a FOIA for every single flare management plan they have in the file. We get to do that little review too. I'm sure some people will have some interesting ideas that, hey, that was a great idea. We should consider that. And the agency perfectly fine with you amending your FMP to adjust your baseline. There's no problem in, as they tell us, no problem in adjusting your baseline if you have new data. So I'm quite sure it'll be a lot of fun. We are 200 people did this.
Speaking of that quickly, why on earth are they listing some of these in the docket going outside of FOIA? Have you noticed some of those?
Yeah.
I have.
Why are they doing it?
Yeah.
I have no idea why they made that. We're all, we figured that out.
Yeah.
I can all retire.
And one thing to think about too is for the flaring consent decrees for refineries, they also have a total flaring limit. And there's a nice little equation in there that tells them what their limit is based on complexity and throughput. It's going to be interesting to do that comparison of using that equation for a refinery. How does their baseline stack up with that? And you know, you can only imagine what EPA can do with these numbers. So now they're going to get all these plans in, and they're going to say, okay, I have 2 refineries with similar throughputs. Why do we have such significantly different baselines? And start going to one and saying, they have a, like, say, whatever the number is, lower baseline than you. Did you truly minimize your flows? And, you know, there could be some added scrutiny from that. So, you know, it's one of those things that we won't know until everybody submits them. But there could be some follow-up questions for people with high baselines without good justifications.
Do we know how many FMPs have been submitted so far?
We FOIA'd them originally, and there were like 10. We FOIA'd again for the period after that first submittal, maybe 6 months ago, and there wasn't any more. So I think everybody's basically holding on till the very end, which, and then nicely enough, you can just email in your FMPs. They provide a nice email address in the rule. I got the pleasure of emailing one in for a client, and you don't get a return email saying, thank you, we received your FMP. No, I knew it got in because I got a call from the EPA saying, hey, we got some questions about your FMP. And so I knew it got in. But if you're thinking like, you submit something via, return receipt requested, you don't get any sort of feedback from the email address. So what's your comfort level with that submittal process? You'll have to do or decide.
So once you do this analysis and you find a baseline and then you decide to put in flare gas recovery, what's your baseline number then?
You're going to have to reevaluate your baseline because it will because you'll be changing your baseline, and there's 4 triggers for resubmitting your FMP. One of them is changing your baseline or installing FGR. So those are automatic. You must resubmit your plan. So you will be doing that analysis again.
So the baseline can be secret.
Yes, and so like if you have a flare gas recovery system that's sized to capture all routine flows, you're pretty much looking at 0 or your purge gas rate. Unless you have some routine event that's going to cause the compressors to be taken out of service. Well, the purge is going from the water seal to the flare. The flare gas recovery is sucking everything else back.
And it's not reportable until it's 500,000 above.
Mm-hmm. Yeah. Okay, so for the instrumentation, you're going to need a QA/QC plan that's required under Appendix B and F, where this is just a good place to document, what's your QA/QC process that you're doing. It's a good thing. So then you can also have an easy way to talk to your I&E guys and say, okay, this is why we're doing the daily cals, why we're doing cylinder gas audits. Are we doing an alternative RADA or versus doing a full-fledged RADA? This is a nice place to document that. So just everybody's on the same page. Record keeping, just quick, keep a copy of your FMP. If you have any sulfur exemptions, you need to have documentation of that. And just these are for an RCA, the things that you're going to have to document. So, 265 days to go. Hope you... 266 days till my vacation. We're running out of time. We started telling people do something quickly 2 years ago, and now we're down to the wire because lead times for instrumentation are long. We are now, I'm talking to some people here, and they're saying, we don't know if you ordered today how soon you could get your device. It's going to be a long time. So if you're not a refinery and you're thinking about putting in some instrumentation, you may want to wait just a little bit. Let all these orders clear out, and you'll get some maybe more realistic lead times. Just some different dates, but pretty much everybody's running up on the November 11th date. Okay, so the weeds. APIs submitted some comments. EPA responded, some of them. Some of them they said, if we respond to this, it would require an amendment. So we haven't seen any of those yet. And then 6 are under further evaluation. I wish I could just answer everybody's question with, you know what, I'm going to think about that. And I'm not going to tell you when I'm going to stop thinking about that. Probably after the due date, I'll stop thinking about that. So it covered a wide range of topics. So anything from what's a flare, a lot of flow monitoring or monitoring questions. One of the big things is people say, what constitutes an interconnected flare gas or interconnected flare header? This was a one that came up, we've seen it a lot, is they're like, well, yes, we have 2 flares, and yes, there is a crossover point. that has never been used. We installed it when we thought we might want to take that flare out of service and send everything to the other flare, but then we figured out that we don't have the capacity, so we can't do that. But we still have this valve that has never been opened. Is that an interconnected flare system? And it's like, well, you have the potential to open it. So I mean, what's to stop somebody from going out there and opening up that valve? So it's kind of like you take the conservative route. It's, yes, that is an interconnected flare system. You know, if you want to argue that it's not, that's an argument. We can do that, but you know, it's going to be an argument.
What's the consequence of having the thing interconnected?
It becomes one flare system. So where you had the 500 pounds per flare, if they're interconnected, now you have one. So you effectively cut your sulfur emission allowables by half, by each for the whole system. But okay, this was another thing. Is do the flow triggers for an RCA event apply for an FGR outage? Because what's the reason for the FGR or for the RCA? Well, the compressor went down. It's like we had to take it out of service. Well, yeah, now you have your reason. So why wouldn't that be covered under the exemptions that you documented in your FMP? So they're going to think about that one though. They didn't have any answers. Yeah, this is another one. A lot of questions around this. If you're taking a compressor out of service, you know, what are your requirements for monitoring? If you didn't have to put the monitoring on, but you're going to have to, you don't have these, you're going to go over your 4, you know, for different periodic maintenance events. You know, is that, you know, why are there exceptions to that kind of monitoring? Yes. Yes. Yes, I got beat up in my early career saying never put the word all in anything, but EPA didn't get the same lesson. This was a good one. And you're using you have your H2S SEMs, and you're looking at doing a performance test of those SEMs. But you only do the performance test if it's an emissions limitation in 102A. But the H2S concentration limit is in 103A. So it's not in the section that it's referring back to. Is a performance test required for demonstration of the limit? That's, you know, seems pretty straightforward, but it's one of those things that when we saw this rule came out and we saw the 162 in the section 103 instead of 102, it almost felt to us like they put it in the wrong spot. They wrote the rule like it is an emissions limitation, but because it's not actually being emitted, it's not an emissions limitation. So it got very hard for them to deal with that, and they still are not answering that question.
I thought they fixed that in the refinery sector.
Yeah, in the refinery sector rule, this was the one thing that they fixed. They said, yes, you must do a performance test.
Yeah, the not routine versus non-routine flow.
No, they added the citation of 103A to performance test requirement.
Oh, okay. I remember that.
I think Ken did.
Okay, go with Ken. Okay, this is another issue that we've come up against, and we'll show you some charts tomorrow, is the flow meters. These flow meters that have to be ultra precise, down to 5% accuracy, or 10 scuff per minute, and no, cubic feet per minute. So then, but when you have a very, very large header and you have these very low flows, you cannot see the flow. The flow meter just cannot see it. The flow is too small. You know, and these flow meters are the best of the best, yet they cannot see the flow rate, and yet this is what's required. The enforcement understands this. In the consent decrees, they were given, you know, you're given a 20% accuracy between 1 and 0.1 feet per second. You know, then once you get beyond 1 feet per second, you're back up into the 5% world. But in NSPS-JA, the rule writing, and we'll see this again in MAC-CC, they don't understand the technology to give you the greater accuracy, or the 20% as opposed to the 5 down at that low velocity. I think they're being taught, and one thing I learned from just a few questions that we posed to the EPA was, if nobody commented during the comment period on a topic, they didn't go back and think about it again. So it's like, we say, well, there's this issue, and they say, yeah, nobody commented on that, so we never thought about it. And so it kind of was a wake-up call to me that, you know, when we have these new rules come out and there's a comment period, comment on everything. Because otherwise they will say, we didn't know there was anything wrong with it. We gave you an opportunity to comment, and if you didn't comment, we didn't go back and look at it. We thought it was fine. So it's kind of a lesson to everybody to, you know, we only get a short amount of time to look at these things, but it is very important to submit those comments. Okay, so you were given a handout. That's the one we handed out later, the 11/17 chart, and I'm not going to go into this in much detail, but this is just a flow chart because we started getting into these conversations as to whether or not an event is recordable versus reportable. And after going through the rule in circles a whole bunch of times, we said, hey, let's create a flow chart. So I'll just let you guys look at that. If you have questions, we can talk about it later. It's just showing you how convoluted it got to decide whether or not things were recordable and or reportable. Okay, so amps. Every flare system is unique. We get shown this every single time we see flares, and I just marvel at the ability of people to do something differently. So the rule is going to force people into situations where they're not going to be able to comply easily. So now's the time to say, okay, well, is there another way to go about this? You know, for my system, which is unique, is there a better way for me to comply with the intent of the rule? And the answer a lot of times is yes. One of the big ones that we've seen multiple refineries get is people who had emergency or secondary flares that weren't behind a water seal. You know, remember I said the definitions for emergency secondary flares all had a water seal in the definition. Well, if you have, say, you know, control valves with a buckling pin or a rupture discs, or even PSVs going to an emergency flare, you know, can you use that exemption for that type of flare? The answer is yes, but you have to ask for an amp. And they have been granting these amps. So it is something that, you know, you can do. And we saw that, you know, the basis for that equivalency is in the definition for the flare gas recovery system, where it talks about having a water seal, a rupture disc, or a similar device. It's all the concept of just keeping that gas from the flare tip. If you have a means to do that, then you can use those exemptions, but you have to request the amp. Okay, there's another issue, the high H2S issue. And I'll just touch on this. I know they're going to talk a lot about this tomorrow. But, you know, we have this, you know, to do the span for the calibration according to Appendix B, that calibration gas must be within 50 to 100% of the full span. And now we have this requirement to have an instrument that's spanned to 1.1 to 1.3 times your maximum anticipated sulfur concentration. So what if you have an acid gas flaring event and you could get maybe up to 80%, 90% H2S in your flare gas. Now you have to have an instrument that span basically up to 100% H2S. So now you have to be bringing in a cylinder of gas. I mean, we're wearing these monitors that will alarm at 5 ppm, to then you've got to bring in a cylinder that could be 50% H2S in it. I mean, the safety issues around this are tremendous, and everybody should spend a lot of time thinking about this. But one of the things is we're already, it gets into the issue of linearity in the monitoring device. We're already just doing 2-point calibration and assuming linearity. You know, we have that point within the 0 to 20% and then the 50 to 100%. And that's how you're doing your daily calibration drift. So we're going to assume linearity between those 2 points. Why does that higher point need to be from 50 to 100%? If it's linear, it's linear. So why couldn't we say, instead of using 50%, why can't we go down at maybe 10% or 1%? And we have heard of a couple of the instrument manufacturers have done the testing to show that their instruments are linear over the entire range. But, so it says, can you take that information and request an amp and say, they've shown that they're linear, why can't I use 2 points with much lower concentration gas and use that for my daily cals? Again, it's a great idea. Requires an amp. We found out that one refinery has requested this amp, but they have not heard back yet on that amp. So we think it's a great idea. We think all of you should do it.
When that amp gets created, is that generally available or has to be requested by site?
Site specific. Like sometimes, and I'll talk about this on Wednesday, sometimes amps are posted to the ADI. Other times they're not. And if you try to FOIA amps regarding this of an industry, EPA will tell you no. It's too broad. They would have to go into every single facility's files and see what amps they would request or granted. So if you can narrow it down and say, I want the amp from this facility on this topic, then you have a better chance of getting that FOIA.
There's actually 2 kinds of amps. There's an amp that you can get for individual facilities that you have to request for. These are the kind that are posted on the API website. There's another category of amps called a broadly applicable alternative method. And these methods, once they issue it, anybody can use it. They don't have to request individual approval. And so this sounds to me like something that someone should submit for a broadly applicable amp. It goes to a different office. It goes to OAQPS, so it's the Austin Furnaces of the world that approve these things, not the individual regions. And they have a special website where they post all of these.
Yep. Yeah, I'll be showing, that's Wednesday. And I've seen yours. Yeah. Yeah, no, it was interesting when I was on that website. I was looking and I was like, oh, Ken.
I try to get all the amps through that.
Yes.
Because, you know.
No, it is a good idea.
One approval letter versus, you know.
And it's how does everybody else find out about it? That's the thing is, like, there could be a great idea that a facility got an amp for. We have no idea how to get that information. We wouldn't know. So.
Publish these in the Federal Register.
Yeah. So that is a good idea.
Good question.
Yep.
So what if you use a different technology to remove the H2S that's not a fuel gas recovery? And does that matter if you're upstream or downstream with the water seal? Does that throw them into the alternative monitoring? And I ask the question because we have a client that's doing an outage. They're going to be de-inventorying their system. Typically, H2S isn't an issue. If there's one event, they're going to have an issue of H2S that they got to remove before they get to the water seal.
So they're going to have.
They don't have flare gas recovery.
They're going to have H2S higher than they normally would just because of this one special case.
Right.
generally my answer would be that's now the maximum anticipated sulfur concentration that they're going to see for the root cause analysis, which would then push them.
Once it gets into the flare header, then you have to address it.
Well, once it's seen by the analyzer.
Okay, I guess that's my question, is if you do some other process to remove it ahead of that.
Yes, it's what's that analyzer going to see, because that analyzer is measuring the gas going to the flare tip. So if that flare gas is treated before it gets to the flare tip and before it is seen by that analyzer, then it's like it was never there.
Okay, but how does flare gas recovery fit into that then? Because you're going to be ahead of the tip. The monitor's still downstream of the flare.
No, a lot of times that monitor then you can put the monitor downstream of the water seal. So some people do that, some people don't. Some people want to know, you just want to know that compliance number, that I want to know what's past my water seal, because then I can say, yes, that's going to the tip. But then you're going to be measuring, you have bought expensive SEMS to measure natural gas. So a lot of people don't like that. So they put it upstream of the water seal. But then you have to have a way, again, additional monitoring on your water seal to be able to invalidate the data when the gas is not going to the flare tip. So it is possible to put it in either place, just you have to handle the data a little differently.
I'm hearing the question a little differently, so I'll pose this to the group, and you correct me if I'm thinking wrongly than what you were saying. A treatment system for H2S versus flare gas recovery for volume. We were talking about baseline. The volume of recovered gas goes over 500,000 SCUT. I need a root cause analysis for that, right? I've exceeded the value. If the flare gas recovery system is out of service for a maintenance event or routine event, and you create an alternate baseline for that case when the flare gas recovery is out of service, we think yes, you should be able to have an alternate baseline for that case. Totally different is the sulfur, the H2S numbers. You're saying there's a treatment system in line because the plant normally is over 162, and I got to keep that system running all the time.
Right.
If it's shut down or bypass, I'm exceeding the 162, right? There is no alternate baseline for 162. You turn off your system for bypassing for any reason, if you go above 162, 3-hour rolling average, that's an exceedance, right? Does everybody agree with that?
See, I was thinking it was more like if you were going to have an outage of your normal treatment system, could you inject like a scavenger into the header to?
And that's where I'll.
Yeah. So you're using an alternative treatment technique during that event to keep yourself from seeing the high sulfur.
And that's where I was going. And then my question is, does it matter where you are in the flare header? Upstream of the water seal, downstream, head of the monitor, how does that get you out of having to do an alternative monitoring plan?
I think you're stuck. I think you can't go over 162.
That's the driver.
Yeah, because the gas you're seeing would be still normal routine gas, not process upset gas.
The only excuse that it came to a relief for us.
Okay, and then I'll with this cylinder gas stuff, the guys from Air Liquide will go into this in a lot more detail, so I'll leave it at that. So that was JA. Any questions? All right. Well, then Tom will go into Quad O.
Let's do an agenda tag up. So I know I could talk for probably an hour or an hour and a half on Quad O, and based on the room, I saw maybe potentially one person that has midstream, upstream impacts on Quad O. You over there? Danielle, I caught you earlier. Does anybody else dealing with Quad O in their daily, weekly, yearly lives? Okay. I still think there's some interesting things about, thank you. Let me put this on. I still think there's some interesting things that it's good to know what's going on in the industry. So I'll try to share those quickly. And I didn't catch your name. What's your name? Whitney. I'm here all week. So under the connection part of the conference, I would love to connect with you and talk more about this because my background, it's funny, Troy, you did subpart W on the greenhouse gas reporting. I was in a oil and gas upstream company for 3 years when implementation of Quad O and subpart W was pretty much a year and a half of my life. So if you're still in it and still doing the control requirements, that's actually starting to get to the point where you want to be able to demonstrate compliance. That's something I'm kind of removed from now as a consultant. So I definitely want to connect with you guys, but I'm going to move pretty quickly if there's no objections and maybe try to do it like Troy did earlier, because tomorrow, I think that means CC in the morning, Mac, CC in the morning, and we'll wrap up at the end of this talk.
This will be the last talk.
All right, let me see if I got these things going. All right, so Quad O. So I'm going to go really quick. You guys got to stop me, ask a question to slow me down, and we'll see how quickly these slides go. I was really going to cover 2 things. I was going to cover Quad O at a high level. Since this is a flares class, this presentation is focused on the control requirements. I'm going to try to stay there as much as possible. And then I do want to touch on Colorado, and I can flip through those slides very quickly. But it's very interesting to see what Colorado is doing in this segment. And I think it's something for y'all to think about. Most of you in this room have been dealing with flare issues now for over a decade or more, and the oil and gas industry is really getting a lot of the public's attention right now with, I don't know if you guys have seen the satellite pictures of the flaring in the Balkan and the flaring in Eagle Ford. I mean, that is a lot of public attention. So I'm going to quickly touch the history and timeline. I'm going to touch on the new rule that just was published the last day of last year. That had to have been a deadline that the EPA had to meet. Applicable sites, control requirements, and then Colorado. So oil and gas, what was unique about this rule was it was the first rule to try to regulate emissions from hydraulic fracturing. So it got a lot of public attention over the last 5 years. Like everything typically coming out of the EPA right now, it was as a result of a lawsuit in 2009, I believe. I think that's on my timeline. And that's really where it started. And let me go on some key dates here. Which button is the laser? Huh? Middle. All right. So I'm going to go over this again, but some key dates. The rule was proposed, the final revisions, August of 2013. Those are the applicability dates. Everybody in this room, I think, is familiar with New Source. It's based on new sources. And then we went through a round of revisions, mainly to address storage tank issues. And then these, what I'm calling stage 2 revisions, just came out. And the industry is, in some respects, still trying to figure it out. And then you probably heard it in the news, especially the folks that are involved in the upstream, midstream segments. The White House came out and said they're going to do more. And kind of like some of the other rules in this class, they're looking at mid-year, seeing some additional proposed rules that are going to affect Quad O. Let's keep rolling. So what were the latest revisions? For folks that do Title V deviation reporting, air permitting, there's a lot of comments around the word responsible official. Some of these oil and gas companies can be very small, so they allowed for small companies to, I think it's less than 250 employees, to basically say you didn't have to get the president of the company to sign off on the report. And so that was nice. They had some clarifications on basically backing off with, for you large companies, it's still pretty much the same. It's going to be your operations vice president, that equivalent, to sign off on these reports. For the lawyers in the room, if there are any, they took out some affirmative defense provisions that won't affect most everybody. Okay, well completions, I mentioned it already. Folks that aren't in the rule every day, the rule regulates emissions from natural gas, hydraulic fracturing, and flowback. Most of the oil wells being drilled in the country over the last 2 years are oil wells. Those are not regulated. And that's a real eye-opener for those that aren't familiar with the rule. It is a natural gas well. It is regulated under the rule. Oil wells are not. Most of the flaring that I already mentioned in the Balkan, Eagle Ford, and places like that are associated gas flaring from oil wells. So if I were to guess, and I'm not ready to take bets yet, if I were to guess, that is going to be the topic of the new proposed rules. I just can't imagine that the EPA is going to turn away from that any longer. So what did they clarify? The industry commented that when you first start a flowback, you just can't run a separator. And there's no way to take the little bit of gas that's coming with mostly water and separate that and use it for constructed purposes, i.e. putting it in the sales line. And so they basically said this was nice. This was response to industry comments that if you're in the initial flowback stage, you don't have to control those emissions or route them to a sales line. But very quickly, especially in most of the high pressure wells that most everybody's drilling today, you're going to be very quickly, if not almost instantly, in the separator flowback stage. And that is where you have to control the emissions. And so the rule clarified and gave industry a little bit more leeway on, really we're talking the first 4 hours of flowback maybe. And it just really depends well by well. I'm going to keep right on rolling. They also clarified potential to emit. Now in our oil and gas essentials class that I'm teaching on Thursday, we go into great detail, rule by rule applicability, and the clarification here really is controls for storage tanks, which is a big part of the rule. And if you are using control devices like a vapor recovery unit, that you can take credit for. And if you are running that vapor recovery unit and you're less than 6 tons per year, you can be out of the rule. For flares, since this is the flares class, if you're using that as your control device, it has to be in a federally enforceable permit or letter or mechanism to take credit for it. And most of the industry is still highly unregulated. They have regulations where submitting a permit is not required if it's a certain size facility. And so most folks don't have permits. So by definition, they're going to be in Quad O. I'm big on this one just because, and maybe we can talk more later, is in my opinion, the EPA really confused the rule with this last round of changes around the storage tanks when they started talking about the word parallel. So they talk about tanks going out of service and coming back into service, and they start talking about if you have tanks in parallel service. I'll touch on that briefly a little bit more in a minute, but it is just, to me, very confusing with the latest definition that they came up with. So you have to know where you are in the natural gas transmission segment to know if you are affected by this rule. So first, you got to know what segment you're in. And then I'm just going to quickly move on. So this is a nice picture. There's about 4 or 5 different pictures floating around. This is one that we use in the class. So if you're up in through here, you're part of the rule. Up through here, you're part of the rule. If you're in the blue section, once you get to the refinery, you're not subject to Quad O anymore. So we use this all throughout the about 3 hours of training to go through each part of the rule. So what are the affected facilities? So you have the applicable sites, and then you have the affected facilities. So this is what the rules are controlling emissions from. Gas wells, centrifugal compressors, reciprocating, pneumatic, natural gas pneumatic controllers. If you have air at your plant, they're not applicable to the rule. So we're talking methane, natural gas emissions for this rule. Storage tank, fugitive components, control device requirements, and then natural gas sweeteners. I had this table up on my wall for over a year, probably going on 2. I mentioned I was part of Subpart W implementation. So just to really, again, to hone in on, am I applicable to the rule? Natural gas, so let's just say reciprocating compressor, very common in the industry. Almost every facility has a compressor of some sort. You started getting into the centrifugal compressors when you're in a natural gas processing plant. So if you're at a gathering and boosting station in Quad O and you have a reciprocating compressor, you are applicable to the rule. You have control requirements under Quad O. In subpart W, it's just the opposite. If you had compressors at a gathering boosting station, you're not subject to subpart W. So again, this was a very helpful table that I referred to very often. Why are the control device requirements for this room X'd for every segment? It's mainly because of the storage tanks. So storage tanks have control requirements, i.e. that's why this whole thing is every segment, every through the processing plant. So I'm going to turn a corner here and talk about the control device affected facilities. Centrifugal compressors and storage tanks and gas wells were what had the control device requirements. Reciprocating compressors is newly added to those requirements. If you actually look at the rule, I think there's going to have to be some technical corrections at some point, because I think it was their EPA's intent to have some of the same control requirements for compressors apply to reciprocating compressors, but they just didn't write all the parts of the rule that way. So it'll be interesting to see how that shakes out. I think it's technical and I think pretty minor. So centrifugal compressors, not heavily used in the industry. Maybe when you get more in the natural gas processing plants, reciprocating compressors, there's hundreds if not thousands of them throughout the upstream, midstream markets. The rule covers both. This is interesting, and this is something that kind of took the industry by surprise. We've been tracking engine manufacture dates for NewSource forever, since Quad J, Quad I, some of the other NSPS NESHAP rules have been around. But over time, these compressor skids and engine skids come from the factory mounted together, but then over time you want to derate your compressor, you swap out an engine. Over time they basically have different manufacturer dates, and so it's just a good reminder that if you're in the industry and you're working with a vendor, usually a rental company, you want to make sure you get the manufacturer date of the compressor part of the skid for this rule. And it's shocking. You'll find out that there's skids that are mounted that have 5 years between the engine date and the compressor date. More than likely, the engine crapped out, the engine died, and they had to replace it. So you think your compressor is part of the rule, and it's not. I just like this picture. Some of your options on a centrifugal compressor. I think I'm just going to move on. So here's your flare. You can go to a boiler. You can go to a compressor. So these are all options that are allowed under the rule. These are your emission reduction requirements. We've been dealing with flare conversations all day. Pretty much in Quad O across the board, the minimum requirement for control is 95% emission reduction. So a little bit less of a requirement under flares compared to flares, but still a high standard. 20 ppm TOC, and if you're using a combustion device, a minimum combustion zone temperature of 760 F. Okay, combustion device. Initial test is allowed by the manufacturer or the owner-operator, and I'll go into that in a little bit more detail. But basically, if you have your manufacturer test and it's approved by the EPA, there's actually a link to a website I'm going to show in just a second, then you can use the manufacturer's test. And as a general rule, I'd say industry is just trying to do that wherever they can. Why wouldn't you? When the rule was first proposed, there were gobs of testing requirements that over time the comments did work, and they started backing off from some of the testing requirements. A recurring test every 5 years, not required if the manufacturer did the initial performance test. I mentioned the links. They're straight off of the EPA website, and I know you guys can't read this, nor can you read it in your book. I just wanted you to highlight that it is being updated on a regular basis. This was January 5th of 2015, so pretty much brand new. And so the previous one was about half this size. So these are getting reviewed and they are getting approved. And it's important to know, if you're working in that segment, who you can work with that has manufacturer's tests that are already approved. You'll notice quite a few still under review. So make sure you're aware of that reference. Flares. Initial performance tests must be conducted by the owner-operator. I think I want to add something to this bullet. That's your visual emissions requirement, method 22. So I think when it first came out, they were talking about doing actual performance tests, and for flares, obviously that would be a real challenge, and now we're talking about just visible emissions. Recurring tests not required as long as you are complying with our favorite 60.18, which is pilot flame presence, visible emissions, less than 5 minutes every 2 hours, normal stuff. Normally unassisted flares, you don't have steam boilers out in the middle of the oil patch. So we're talking unassisted flares with a BTU content greater than 200 and exit velocities less than 60 feet per second. We were talking about the names of these different types of flares. This is most likely a very unengineered flare. I like to call these utility flares. It's basically a pipe on a stand. They are getting more sophisticated as time goes on, but these are still out there. Okay, turning a corner. Remember, I'm staying on control devices and moving very quickly. This is the part of the rule that really affected industry. The EPA said in some of the early preambles that they completely underestimated the number of storage tanks that were going to be applicable to the rule. I think the original rule that was published said across the entire country there's going to be 300 tanks that may be affected by the rule. There's thousands of tanks that are affected by the rule. So, and especially with the boom that's been going on for the last 5 years. So when the round one of revisions came out, the EPA was very generous in recognizing there wasn't enough control devices to go around to control all these tanks, so they implemented a phase-in cycle. They actually gave you more time to control your Group 1 storage tanks than the ones that were built later. Obviously, we're talking retrofitting your facility versus having the flare or combustion device there when you start up. Very much easier from an engineering standpoint. So as we're implementing this rule, this is one of the few dates in the entire rule that are still left to come. It's later this year. All right, I mentioned this before, but and I won't go into too much more detail. It has to be a storage tank greater than 6 tons per year emissions to be an affected facility. There's outs. If you're working in the oil upstream business, gas, you have these large decline curves, and you literally can move your control devices around the field. And so there is an out that you can remove your control device if you're less than 4 tons per year for 12 consecutive months. Makes sense. You can move your control device to a newer well that was just going to come into production next month, let's say. Just a reminder, there's always catch-alls in the rule that say if you refrac a well or work a well, and you're going to go back over that 4 tons per year, make sure you have your control device there. And in the interest of time, I'm going to keep on going. This is where parallel comes in. So just real quickly to tell you the story, because I think it is probably the most controversial part of this revised rule, is I'm finding out mainly through hallway conversations. You talk to people at conferences like this, and you have, let's just do real simple math. You have a facility with oil throughput that gives you with flash emissions 15 tons per year annually average, and you have 3 tanks, that's 5 tons per tank, and so you would not have those storage tanks be an effective facility. 15 divided by 3 is 5. Very simple, right? Well, now I'm hearing that folks, in my opinion, weren't using good engineering practices or best accounting practices, if there's any accountants in the room. They were trying to divide their total emissions by the number of tanks that they had, but they were sending all their oil through the first tank. You can't do that, okay? And so I wasn't personally involved in those ways of thinking, but now I'm hearing that that was a big deal. So essentially you had 15 tons of emissions coming from your first tank. That would be an affected facility. So I think the EPA caught wind of this. I'm not sure how, but they're basically saying if you bring on a new storage tank in parallel with your oil tanks and you had an effective facility already, you better start up with your controls in place for the new tank or replacement tank that's coming on. So it's just very interesting to see how the industry is going to respond to this revision to the rule that was not in the proposed rule. So no chance for comment. It literally went from not in the proposed rule at all to here's the rule, and oh, by the way, we changed the definition of a storage tank. So really interesting to see how that shakes out this year. All right, performance tests. The rule had a lot of performance tests in it. Basically, they backed way off of that. There was really, in my opinion, practically no way they were going to comply. Industry was going to comply with all the performance test requirements. So combustion device, not required. Reoccurring test, not required. So that's really, really nice. If the manufacturer proved it's a good working device, that's what you're going to use for your performance test. Again, around flares, performance test, initial test was not required. So again, the rule backed way off from what was originally proposed a few years back. Okay, just some catch-alls, really important practical stuff. If you are going to use the manufacturer's test, make sure that it's at a flow rate that was done for the test that was less than what your facility is going to run at. So don't try to use a performance test that's not applicable to your facility. So just be careful there. They do have specific requirements there to make sure you're properly applying the manufacturer's test. I'm going to keep on rolling. There were inspections required under the rule, monthly pilot flame presence, basically leak walk downs. These are, visual inspections, and basically no smoking. That's stuff you guys have been dealing with for 2 to 3 decades now. Monitoring requirements. There was no requirement for a monitoring, continuous monitoring parameter that you had to keep records of. I'm going to keep on going. Hydraulic fracturing. Okay, this one's interesting for the room, just so you know. They specifically in the definition of the rule said that if you're going to use a completion combustion device, that's a new definition under this rule. It specifically says is not a flare. It's in the definition. So if you hear the term completion combustion device and folks are using a flare, essentially, what they wanted to try to give the industry some leeway on is compliance with 60.18. They didn't want people, those utility flares that I showed you, to be worrying about is that utility flare 100% in compliance with 60.18. So they basically came up with their own definition of a completion combustion device and said as long as it's getting 95% emission reduction, you're okay. Whew, that was a big deal. That was a big deal when the rule was first proposed. And so it's good for you guys to know when you do see those flares going off, they are, in most cases, completion combustion devices. Okay, for wells that are now coming in this year, you have to do, in the rule, it doesn't specifically use these terms, but a reduced emission completion or a green completion is what's being used in the public. Well, remember I said this is for gas wells, and thinking simply, it doesn't address the associated gas issue, because why, if you're drilling for a gas well, would you start up and want to flare all of the gas that you're trying to sell? So it just really hasn't hit the industry yet, because the real next big step is what I've already mentioned, is dealing with the associated gas flaring. The rule gives outs for low pressure wells, wildcats. If you're out in the middle of nowhere and there's no way for you to get to a sales line, there are some provisions in the rule that let you still use a completion combustion device. So that's good to know. I'm going to keep on going. This is one I wanted to touch on. So, so there's spark ignited flares, basically to get them relit, that is not allowed under the rule. It specifically says a continuous burning pilot flame. So the industry really had to adjust to this, and you'll see these large propane cylinders out on a completion site where they're basically running their flare on propane, their pilots, to keep them lit. So this was a big battle between industry and the EPA and the regulators. And so far, the EPA is holding their ground. They're not allowing spark igniters. I think there were some conversations earlier today. They're really concerned about flares or completion combustion devices becoming stacks and not being lit when they should be. So if you are running a completion combustion device, you got to have a pilot flame all the time. All right. Why I wanted to touch on Colorado. What time is it? I said I would try to. Oh man, I'm doing good. 4:55. I got 5 minutes. I was going to try to keep it to 30, 35 minutes. So I'm right on track. Colorado is, from a regulatory standpoint, ahead of the game. And in my opinion, all these announcements that the EPA and the White House came out with in January, I think are very much going to fall in line with some of the things Colorado's doing, just my opinion. So Colorado really stepped out about 2-3 years ago, and this was big news in the industry. Thief hatches, which is your gauging hatches on a oil and gas tank, those in the industry have a long history of being either left open by your truck driver that's picking up the load, or the gaskets and the springs that hold the thief hatch down and make it work properly are not being maintained. And so basically the Colorado regulatory agency came out and said, if we find a thief hatch problem, we are going to fine you $15,000 a day. So that got a lot of folks' attention. Then they came out and said, we're also looking at proposed rules that are going to bring LDAR, leak detection and repair, in the industry. Those rules are now proposed and final. I need to get this bullet updated. I will. So they came out in February of last year and said, we really believe in this. This is the reason why we believe in these rules. And this was Colorado's process to fully implement Quad O at the state level. And I love this word right here. CDPHE is going to expand oil and gas control requirements and establish additional monitoring, record keeping, and reporting requirements. Wow, they are, it's not good enough to just comply with Quad O in Colorado. So they did. They revised what's called Colorado Reg number 7. They put, this slide really addresses general duty clauses for you flare folks in the room. Your air pollution control equipment must be operated in a manner for minimizing emissions, including times during startup and shutdown. Boy, that's a catch-all statement. So you got to make sure your device, your utility flare, if you will, is lit all the time and is operating properly. Combustion devices combustion device enclosed and no visible emissions, so you can't have bypasses and find out that maybe a safety relief is always open, things like that. Combustion devices, this is nice. Colorado took a step back from the EPA, and they are allowing auto igniters, but if Colorado is allowing auto igniters and Quad O is not, so how are you going to be in compliance there? So there's another good one. But Colorado said we will accept auto igniters on your combustion devices. I'm going to keep going very quickly. Open-ended lines. If you're in the LDAR world or had been in your past careers, there's really no overriding federal level LDAR requirement for the upstream segment. So Colorado basically expanded their LDAR provisions to cover all of the oil and gas upstream segment, and it just started. So they pulled it all in. Compressors, I mentioned those briefly. they didn't do it for just the new compressors after the applicability date of Quad O. They said if you operate a centrifugal compressor, you will be in compliance with the control requirements by January of this year. So again, a large expansion of Quad O, in my opinion. Reciprocating compressors, the main part there is a rod packing replacement every 36 months. Again, instead of just for your new compressors that Quad O addresses, this applies to all reciprocating compressors in your field. And they gave you a little bit of notice, but basically you now need to be in compliance with all of your compressors. Doesn't matter when they were built. Storage tanks, I think Colorado did a good job here with their definition. They're trying to address these parallel storage tank issues that I mentioned earlier and came up with a definition that I think, in my opinion, is much more straightforward. Storage tanks means any fixed roof storage vessel or series of storage vessels that are manifolded together via a liquid line. That is a definition straight out of the rule. So their 6 ton per year requirement applies, let's say these first, let's count here, first 4 tanks are oil and then a couple water tanks. Those 4 tanks, if their emissions are greater than 6 tons per year as a whole, i.e. operating like a single tank, then they're applicable to the rule. So Quad O, completely different. All right, another expansion. They basically said your storage tanks, including temporary frac tanks, need to have a control efficiency of 95% for the first 90 days of production. Again, not part of Quad O at all. They basically said you better be controlling for the first 90 days no matter what. So that's, again, another huge step out from the rule. And then they gave a little bit of a different phase-in period. I think you guys can read that there, but essentially the same, and they're just allowing a little bit more time depending on when you built your facility. Storage tanks, some inspection requirements. I'm going to keep on going. You have record keeping. Regulators have a fun time with record keeping. They came up with a new term, at least one I've never heard of before. This is a storage tank emission management system. So your flares have flare management plans. In Colorado, your tanks need to have a storage tank emission management plan. It's very detailed. Those things all must be in a written plan. And luckily, you can have one plan for your entire field, not per tank. So that was really nice. So think FMP for storage tanks. They came up with another acronym I had really not heard before, Approved Instrument Monitoring Method. So FLIR cameras, it's basically a FLIR camera. You can use traditional monitoring with an organic vapor analyzer, or you can use the camera. Sage is really stepping into that market because there's deadlines to have your inspections done, I think, within 90 days. So we have a couple guys out of Denver that are doing a lot of camera work right now. DHIs, I think I'm going to just keep right on going. LDAR I mentioned, it's a large expansion of the LDAR requirements for oil and gas upstream. This one's interesting. I want to touch on this one. Remember I said I think they're really going to touch on oil, gas. This is where they do it. So they basically said if you're operating a well and doing maintenance after August of 2014, gas from a separator during normal operation and any newly constructed hydraulically fractured or recompleted oil and gas wells. So this is where Colorado doesn't make the distinction between an oil well or a gas well. You're in, and here's your 95% control. So there you go. Downhole maintenance, again, if you've heard of well unloading, basically you've got all this water on top of your natural gas. It's just a water column of pressure, and the only way you're going to get your well flowing again is basically bypass the separator and go straight to the storage tank, which means you're going to be sending all your gas that's coming out with the water to your storage tank for a little period of time. You get the well flowing again, you go back to normal. Well, that's basically liquids unloading. There's control requirements around that. A trouble well will be liquid unloaded by the operator every day. So it's something, again, that you think rarely happens, but in the industry, if you have a troubled well, you're basically bypassing all of your separation equipment and just going to the storage tank. And that's going to cause a lot of methane emissions. All right, so what time is it? All right, 5:04. All right, I went really fast. Is there any questions in the room about controls around Quad O, what Colorado is doing? All right, thank you very much. I'll be here all week. If you guys want to talk more about it, let me know. Starting back up tomorrow, Troy, as far as I know, but right back here in this room.
I think the same place.
All right, we will see you all tomorrow, 8 o'clock. Thank you very much.